Hello folks, second time at attempting to start this stream. I hope it works okay this time. This is VK3AML Chris in Melbourne, Australia. Tonight we have just one subject, and that is a lecture by my friend Mike Groth VK7 Mike Juliet. The lecture will be on the history of radio before the development of thermionics. That is, before the development of thermionic valves. I think we've got a stream, I'm not quite sure. No images yet. There we go. And if I look slightly panicked, it's because we had a false start. So let me first introduce my friend Mike Groth after I go on the air. Hello, with a slightly slow start tonight. This is VK3 Alpha Mike Lima with the usual Saturday night transmission. Tonight, a 90-minute lecture by my very good friend Mike Groth VK7 Mike Juliet. Mike I got to know through my work in modulated light communication systems. I've known him for 34 years, and at one stage, as a culmination of a series of experiments we made over a 15-year period, we held jointly the world record DX for modulated light between Mount Barrow in Tasmania near Launceston and Mount Wellington near Hobart. That was back in 2005. Tonight we're going to hear Mike talking about radio history before the development of amplification devices. That is, in that period from James Clerk Maxwell and Michael Faraday in the mid-19th century through to the commercialization of radio by people like Marconi and Lodge, Poulsen and Sir Ambrose Fleming in the first decade of the 20th century. It was a huge leap from nothing to spark telegraphy, and tonight Mike is going to be telling us quite a bit about this. This was originally a lecture delivered to the Radio and Electronics Association of Southern Tasmania 5 years ago, 2017. Unfortunately, their upload was a little bit compromised by being in slightly less than standard definition, so that a lot of the illustrations that Mike was giving up on the screen were sufficiently blurred as to be difficult of intelligibility. However, if you go to VK3AML, 11 June 2022, that is Google VK3AML, 11 June 2022, just checking my transmitter, you'll find a live stream of the video with this lecture. So without further ado, Mike Groth VK7MJ. From Maxwell to Marconi, 1864 to 1914, a talk by Mike Groth VK7MJ, originally delivered in Hobart on the 8th of February 2017. And here is Mike, just to show you what he looks like, or what he looked like at that time. And I'll hand it over to Mike.
Okay, I was going to talk tonight on the first 50 years of wireless. Basically, wireless before the First World War. Before there were such things as valves. If those of you have heard of those things coming in, I think. Radio valves, vacuum tubes, as the Americans like to call them. There were no amplifiers. Well, there were things with carbon buttons in them or something, but they weren't really much of an amplifier. I think they were called ground relays or something. But it was a world, basically, wireless using the technology of the electric telegraph and the telephone, the technology of the day. And they did some pretty ingenious ways of doing it. Now, why 1860... Oh, do I just press this button?
Just press the button, yep.
Why 1864? I really want to cover this period here from about 8 to 50 years. Between 1864, when electromagnetic radiation was actually predicted by James Clerk Maxwell, that's where he comes in, a bit like Einstein, he predicted gravity waves. It took us about 100 years to find it, but it only took 25 years to confirm that these electromagnetic radiation existed. And then there was a decade, the last decade of the 19th century basically, when the first generation of radio technology was developed. And then from about 1902, there was a 12-year window when there were actually practical wireless telegraphy. It was a practical system, and in fact, it linked places like New Zealand, relied on it to be connected to the rest of the world. We were lucky we had an overland telegraph and then underground submarine cables all through Asia. But places like most of the Pacific Islands that relied on spark transmitters to communicate with the rest of the world. And I believe Tasmania did. They had one up in, I think it was Stanley, and one in Queenscliff or something in Melbourne that transmitted through to Tasmania. That was the telegraph network was done that way as well. So who was James Clerk Maxwell? Well, he was Scotland's answer to Isaac Newton, the Scots reckon. Basically, he did for electromagnetism what Newton did for gravity and motion. He took all the studies of everyone else and put the mathematical bit to them. Faraday was a brilliant, absolutely brilliant experimenter, but he had no mathematical knowledge at all. He was completely self-taught. And Maxwell basically took all the knowledge of Gauss and Faraday and Ampere and all the great experimenters and put them down into 4 differential equations. Now, I used to know what they meant once, but I won't pretend to. But the interesting thing that Maxwell did is that Faraday had shown that a chime-varying magnetic field created an electric field, basically. Varying magnetic field generates a current. What Maxwell had done, thinking about what happened inside a capacitor when you charged it and discharged it, talked about a displacement current or a virtual current, and he said, on the grounds of symmetry, this equation term should be in the equation. So he put it in there, and he said if that's the case, then an electrical disturbance will propagate through the ether. Everything, in those days they had to have a medium for waves to propagate in, because sound doesn't go in a vacuum and all the rest of it. So they had to, this concept of the great ether, and we still use it in terminology, but of course we know it doesn't exist anymore. But if this is the case, electrical disturbances will propagate through space, and he calculated the velocity knowing the electrical properties of the vacuum and came up with a number that was pretty close to the best estimate they had of the velocity of light in those days. Strange about that. And he thought, well, I'm probably on the money. And so actually a prize was issued by Helmholtz called the Berlin Prize. I think it was quite a substantial amount of cash for anyone who could demonstrate their existence. And not too many people were game to take it on. They reckon it was going to be one of those things that, a bit like hunting for magnetic monopoles or cold fusion, I think it could ruin several scientific reputations. But telegraph engineers had known for a long time that when you got sparks in one circuit, it often caused sparks to appear in other circuits. And one of the experiments that was done in about the 1830s is that if you got charged up a Leyden jar, which is just a high voltage capacitor, and you short circuit it, and there was another Leyden jar with a loop of a similar size, when you got the spark there, you get a spark on the other one.
And here, courtesy of the Fondazione Scienza e Tecnica in Italy, in Florence, we see the principle of syntony or tuning demonstrated on original equipment from the 1890s. The spark coil is connected to a loop, an inductance plus a Leyden jar, a capacitor, and produces a spark. And we get a similar Leyden jar capacitor and a similar loop of varying length, and you'll see that the second loop can be tuned to coincide with the transmission wavelength of the first loop.
That actually demonstrated electrical resonance, so they didn't know the term in those days. They called it a sympathetic oscillation, or a syntony was the word that was used. And essentially what happens is when you try and discharge a capacitor through an inductor, then of course the current flows, the energy goes from the electric field there into the magnetic field there, and then the current keeps flowing until it charges up in the opposite direction, and it goes back and forwards. A bit like if I hold up a weight on a pendulum, it doesn't go straight to the middle, it oscillates back and forwards and eventually runs out of energy. So a young fellow by the name of Heinrich Hertz, who of course now has his name immortalised, he decided that maybe sparks might generate these electric waves. And so he did a very simple experiment. He made a capacitor, two plates about 400 millimetres square as far as I can determine, about 600 mil apart with a gap in the middle, hooked to one of these newfangled things called an induction coil to generate lots of sparks. And he said, well, if that's the case, there's going to be this imaginary current flowing through there. If I put a loop of wire in there, I should be able to detect that. How did he detect it? He put a tiny microscopic gap in a magnifying glass and looked for sparks. All he had, there was no instruments to measure it. And he'd set it up, and on the far wall of the room he'd put a sheet of zinc. And he argued that that would cause a very major change in the electrical properties of the room, and it should cause a reflection. And if you got standing waves, there was obviously some sort of radiation. And lo and behold, when he fired it up, and he had the electrodes, when he had the plane in the vertical direction, he got plenty of sparks near the wire. Well, that's fair enough. He got a couple of metres out, nothing at all. Got a couple of metres further on, lots of sparks again. And it kept repeating itself. He tipped the coil 90 degrees, and when he got nothing here, he got a maximum here. Exactly as Maxwell had predicted. You got an electric wave and a magnetic wave at 90 degrees to each other and 90 degrees out of phase. So it's just energy transferring from one electric to the magnetic field propagating through. It's got a fun. And he did a whole pile of other experiments. He actually made set of trough reflectors working up at about 400 megs, so it was in 450 megs. He was really up into UHF as well. And he showed that they reflected like light, it refracted like light, it was polarised, all the properties that light had. So this was just like another long wave light. And over in England, Oliver Lodge, who'd been sort of trying to sort the problem out himself, discovered that if he set up a spark coil with a long transmission line on it, as he went along the line measuring the voltages, he got a very high voltage at the end of the line and very little in the middle. And when he turned all the lights out in the room, he could see the corona glow at the ends. He could actually see the standing waves. And he said, the disturbance is going along there, it's got a finite velocity. So these waves do exist. And they tended to be called Hertzian waves or etheric waves, because they're all waves in the ether. It actually took about 6 years for an English translation, but they've shown that people like Lodge read enough German to be able to read Hertz's papers, and Hertz probably read enough English to be able to read. That was sort of expected to be done anyway. And knowledge was very widely shared. There wasn't too much intellectual property worries in those days. But did they have any application? Hertz thought, no use at all. But I proved Maxwell was right. But the other question, can you detect them? Is there a better way of detecting them than getting the spark gap? That's pretty insensitive. And it turned out that telegraph engineers had realised for a long time that powdered metal granules had some interesting electrical properties. If you get some iron filings and put them in a hole with a couple of copper wires and put an ohmmeter on them, looks like a high resistance. Put about 6 volts across it, and then try it again, guess what? It's gone to a low resistance, and it stays there. It's almost as if the particles are clumped together or cohered. And if you tap it, it goes high again. And they noticed that if you were doing this experiment and there was a thunderstorm on, there was a flash of lightning, guess what? It turned on them. Or if someone discharged the capacitor and caused a spark nearby, turned on. Maybe this would be interesting. So the paper was published in 1890 by Edouard Branly in Paris, but telegraph engineers had been aware of the effect for quite some time. In fact, they used to use carbon blocks full of carbon granules as lightning arresters. If there was a lightning surge, they shorted the line out, they just tapped the block again and the system came back to work again. It's just that, like all these things, it was all there, it's just no one recognised it. And essentially, I was lucky, a friend of mine had a copy of James Erskine's Brown Handbook of Wireless Telegraphy in 1908 edition. You can get it on the line, it's available online too actually as a PDF. And this is the sort of typical electrical characteristics of coherer. It gets to about 2 volts, then all of a sudden it turns on. Any nonlinear conductor is a nice RF detector. But it's not only RF, it works on, it's quite immaterial whether it's RF or DC. Any sort of pulse will turn it on. And the best combination, it works for almost anything, but the best combination seems to be nickel filings between a couple of silver electrodes, and it helps if you can evacuate some of the air. That makes it stable. If you just use things like iron filings, then within a few days they're going to oxidise and it's going to be as deaf as a post. It takes typically somewhere about 100 millivolts to turn the thing on. It's pretty insensitive. You wouldn't think it'd be much use as a communications method, but it was. And guess what? Someone's built one, someone's put it on the internet and on YouTube, and people like me come and steal it. So, where's this man? And if I can only... So that's just a couple of bolts with some iron filings in between. Put it in series with LED and a battery with a bit of a aerial on one side. Turns on, you've got to tap it, turns off. Fire the spark again, and it turns on. It's the first spark that does it, the rest are quite immaterial. Now, that's all very nice. Oh, how do I get it? I don't want that. How do I get out of that? That's it. Oh, that'll go back, isn't it?
Right, Eric.
Yeah, that's it. It didn't take them long to realise that if you made the thing operate a relay and the relay operated an electric bell, then the clapper of the bell would gently shake the coherer and it turned itself on. Very simple, crude as blazes, but it worked. And guess what? Yes, someone's done it again.
The transmitter consists of a car's ignition coil, which is used to produce high voltage sparks at the spark gap. This relay has been wired as an oscillator, and it turns the coil on and off very quickly to produce continuous sparks. To reduce arcing on the relay, I use a capacitor which filters out the back EMF generated by the ignition coil. I also use a ballast resistor to limit the current in the circuit. The receiver uses a coherer to detect radio waves. I made this coherer in a tube, and it consists of iron filings between two electrodes. Normally, the coherer has a high resistance, but when it detects radio waves, its resistance drops to about 10 to 20 ohms. When this happens, this bell gets activated and the bell's hammer hits the coherer and resets it. This receiver is also connected to a beagle bone, which decodes the received signals.
Okay, so who was the first person to actually send a message doing this method? Turned out it was Oliver Lodge, because poor old Heinrich Hertz died at the age of 36 on New Year's Day in 1894. He had some sort of strange hereditary blood cancer or something that killed him. And so Oliver Lodge, who'd been working closely with him, gave a memorial lecture and he demonstrated his work. And he attached a couple of electrodes to a coherer, connected to a relay and an electric bell, and sent a telegraph message to the back of the lecture theatre, 55 metres. Not really a communication system, but that's the first known case of someone actually sending a wireless telegraphy message. It was done in November of the same year. A fellow called by the name of Chandra Bose in Calcutta did the same thing, but he went one further. He used it to set off a charge of gunpowder up the back of at some distance, so he wanted a good report. Anyway, not bad joke. Meanwhile, over in St. Petersburg in Russia, a fellow by the name of Alexander Stepanovich Popov, who the Russians regard as the inventor of radio, or the father of radio, he had thought these coherers would be very good detectors of lightning, so he did the same sort of system and built a lightning detector. This is one of his later ones from about 1898. And essentially there's your coherer. That's actually a very sensitive shielded relay, and that operated the bell, and the clapper coming back tapped the coherer, and that operated a solenoid there and put a mark on the recording drum, so it gave the number of lightning strikes. Meanwhile, a young Italian by the name of Guglielmo Marconi, and I think you've all heard of him, Signor Macaroni, as I think some people used to call him, he was following Popoff's work, and he built an indoor lightning detector, and I think I don't have any details, but I suspect the sensor was just an elevated sheet of acting as a capacitor to a coherer. Discovered he could detect thunderstorms. So then he got his he got a spark gap and rigged up, and this time he connect one side to the earth and one side to a similar plate, and he transmitted a message across the room. This was on Christmas Eve. He woke his mum up to show him what he'd done. His dad thought he was playing a trick, realised he wasn't, thought his son's onto something here, actually gave him all the spare cash he had and said, go out and see if you can make it work. There's a few bob and a few lira to be made here. So off he went. And so that summer, he followed the Mythbusters thing. If it's worth doing, it's worth overdoing. So he upscaled, and he got a range first of all half a mile, then he got 2 miles over the hill into the next valley. And people like Lodge had done a pile of calculations, said, look, it's going to be line of sight only, and it will never be detectable at more than half a mile. Well, Marconi had said, you think you know what you're talking about, mate? He thought the Italian government might be interested, so being a good loyal Italian, he offered it to the government. Apparently the government's letter back referred him to the local lunatic asylum. So he said, up yours, mate. His mum was Irish and she had connections to English society, and he thought, the British will be interested in this. So off he went to England. And he got introduced to William Preece, who was the head of the chief engineer with the GPO, and he was responsible for all telegraph communications in the kingdom. So he set up on Salisbury Plain in 1897. He did a pile of tests, and these days, then he gave away the plates. He realised it was just a wire was what was important, and I think he flew them from kites, and the longer the wire, the more range he got. But he got ranges of 10 miles or 16 kilometres, just a simple thing like that. Then he played, this is actually his original receiver. There's the coherer, the tapper and the relay. There's the relay, the batteries in the back. And there's 3 very pompous looking British engineers. I love their moustaches and their bowler hats and their serious look. They nicely posed. I'm sure they spent ages combing those moustaches for the photograph. But over the next year or so, he did a pile of experiments, and he discovered the first improvement: get the coherer out of the circuit, because all the static charges were setting it off. So by transformer coupling it, only the oscillations in the aerial would get through to the coherer rather than the static charges. And lo and behold, it was a lot less sensitive to static. He got ranges of 60 kilometres. And the other advantage is that with a few turns on this and a lot of turns on this, they were just a small air-cooled solenoid, nothing fancy. And I think he ended up with wires around about 100 feet on the 30 odd metres to the kites. He got 60 kilometres out of it. And basically over the next couple of years he discovered the longer the aerial, the greater the range. And basically because the longer the aerial, the longer the wavelength. Better ground wave for propagation, because it was all ground wave he was looking at. And considering that the amount of voltage it takes to turn a coherer on, he's doing pretty good. But when you consider a spark transmitter liberates all its energy in that first, it's a very, very powerful pulse transmitter, even though the average power is quite low. The other thing they discovered very quickly, because Marconi wasn't the only person working, there were von Arco and Braun and Slaby and the Siemens brothers working away in Germany, and they ended up forming Telefunken. Once they started being able to hear each other's transmitters, it was absolute bloody chaos. You could only have one transmitter available at a time. There was no way in the world you could separate them. You had to somehow or other get that transmitter to operate at a single wavelength. And really you wanted something that was a lot more sensitive than a coherer, a dirty contact, that's all it is, as a detector. Ideally something that would turn the radio wireless signal into an audio signal, and you can hear them on a pair of headphones, because you can easily detect signals down millivolt levels on a pair of headphones. or even sub-millivolt if you've got really good hearing. And the other thing is, the headphones allow you to use between-the-ear processing. You can tell the difference between the signal and the static, whereas a Morse seeker couldn't. It was just puts lots of dots and then you had to try and join the dots. A bit like reading a message from the tea leaves. Probably just about slightly more accurate, I think, but not much. So how do you tune a spark transmitter? Now, a spark transmitter is essentially an aerial working against the Earth is essentially a lossy tuned circuit, lossy series tuned circuit. You've got the capacitance of the wire to the Earth, you've got the inductance of the wire, plus any loading coils if you're running. And what you do is your spark coil charges up to a really high voltage, the spark gap breaks down, and that's effectively a short circuit. The resistance of an arc when it's firing is only a few ohms. So it's a dead short circuit. The charge rushes down to Earth, and this goes from a very high positive voltage down to a very high negative voltage, and very quickly it oscillates and the power's dissipated, and then the spark goes out. Very, very high power levels. Even this old girl produces about 100 milliwatts of RF, but the peak power is probably something like 50 or 60 watts, because the duty cycle is so short. All that power's in a few cycles. So your radiated signal is a series of very highly damped wave trains. If it wasn't for that characteristic spark transmitter, you wouldn't get a coherer to work on a CW transmitter very well, because you need those incredible pulses. And the emission wavelength is typically 4 times the length of the wire. So how do you clean the act up? Well, the real problem is that the spark gap is part of the tuned circuit. And if you have a quarter wavelength of wire, you've got a reactive components of about 500 ohms, you've got a resistance of about 30 or 40. So you're going to get a Q of 10, 15, something like that. So you're going to get about 15 oscillations or so before it gets down to about a third of its value. But the trouble is, once the spark stops, so does the oscillation. Surface open. What you want to do is separate the spark gap from the aerial. Get the aerial ringing, take the spark gap. This is a bit like hitting something with a hammer and it goes clang, rather than hitting a bell gently and letting it ring. And the way they did it, it was both John Ambrose Fleming, who was Marconi's chief engineer, and Braun came up with the idea simultaneously. Then they discovered Lodge had a patent on it. But that's all right. Not the first patent dispute Marconi got involved with. He actually had to pay Lodge this time. What they did is, instead of storing the energy in the aerial capacitance, you put a capacitor there. You charge it up to a high voltage. When the spark gap fires, this here is the oscillating circuit. That's a bit too deep. This is the oscillating circuit. That's loosely coupled via what they call the oscillation transformer, or the aerial jigger. Why they use the word jigger, but it seemed to be a slang term for transformers in the early days of wireless. And then you change your aerial to get the maximum radiating current. And if you look at the waveforms involved, you'll see your spark current's fine, but the aerial builds up as the charge builds up. By the time the spark comes, when the spark stops firing, this is now out of circuit. It's an open circuit, and the aerial keeps ringing. Your bandwidth depends on the loaded Q of the aerial. If you've got a very poor earth connection, it's still going to be broad as a barn door, but if you're doing long wave work, when you've got loading coils and very high Q aerials, you could probably get a bandwidth that's sort of 3 dB points, might be plus and minus 5% of the centre frequency. Better than plus or minus 50 or 60% for an untuned spark. And it means that if you've got two transmitters that are, say, 20 or 30% different in frequency or wavelength, as they always used to work in those days, they didn't really have ways of measuring frequency. They could measure wavelengths fairly easily, but not frequencies. Then you could separate them. Once you've got to tune your transmitter, you can tune your receiver. And that's a typical receiver of about 1900. A parallel tuned circuit leaks all the DC off the aerial. You tune your aerial, and it also means that you can have your aerial tuned to the same frequency as your transmitter. Your RF pass is through the coherer and the bypass capacitor, the relay turns on, starts the trembler going, and also puts a line of ink dots on the printer. Part of the reasons for using a Morse inker was that was the technology that was available, and also people wanted a hard copy. They insisted that, I believe in the early days of the telegraph, it wasn't until later on the telegraph operators realised they could read the signal from the clicks and the clacks much faster than they could read it off the tape. But in the early days of the telegraph, everything was done on tape. And lo and behold, he got a range of about 100 miles. This was now a serious communication system, just using some rusty metal to detect it. It really was amazing. Now, Marconi was forever the optimist. He was an entrepreneur, he was a businessman, and he was a showman. He was also a great experimenter, and he knew and very resourceful. He decided his next step, he was going to span the Atlantic.
I'll just interrupt this here to say this is VK3AML with the regular Saturday night test. We're currently listening to a lecture originally given by Mike Groth VK7MJ about 5 years ago on the progress of wireless communication from James Clerk Maxwell to Marconi, and we're about to see Marconi's first spanning of the Atlantic Ocean. If you want to look in on the visuals of this, please do Google VK3AML 11 June 2022. Now you might find a false start there. We did have a false start earlier, but we're the second start for the evening this time. Back to the video with Mike Groth VK7MJ, and we're about to see Marconi do that speculative experiment in 1901 across the Atlantic.
1901, he was getting about 200 kilometres. He shipped to shore stations. He was making good money. He set up a company, I think, called the Wireless Telegraph Company, British Wireless Telegraph Company. He was going to take on the big cable companies. At that stage, there were 5 transatlantic cables between Ireland and Newfoundland, a distance of some 3,000 odd kilometres. So he persuaded his backers to give him a pile of money, and he built a 15 kilowatt spark transmitter at Poulsen in Cornwall. And he built an enormous aerial, some 16 metres tall, in Cape Cod in Massachusetts, and the same thing in Poulsen to do a transatlantic test at the end, towards Christmas 1901. Well, the weather gods weren't favourable. I believe in August a gale took this aerial, turned it to matchsticks and tangled wire, and in September a similar fate happened to the big transmitting aerial in Poulsen. But not to be discouraged, they jigged up a temporary aerial. Those poles are 48 metres high and 60 metres apart, and he had a fan. He'd originally had a giant cone 60 metres high with 60 poles, but he didn't quite guide them right for winds from a certain direction, and the gale took them out. And the weather in Cornwall's probably a little wilder than the weather in Hobart. That's a picture of the transmitter. It was an interesting design. And a little sign says, "Caution, very dangerous, stand clear." Mate, I wouldn't want to be anywhere near it when the power's on. In the background you can just see the main spark gap there. It was actually one spark transmitter running at about 40 kilohertz, acting as a high frequency power source for the next one. It was a problem. They could only get about 7 sparks per second out of it, because when the spark fired, it de-excited the alternator that was driving it. It took about 4 or 5 revs of the alternator for the fields to build up again and start the charging cycle. So it was real hit and miss. But that really didn't matter. When you're doing with a coherer, you only need about 5 or 6 sparks per second. Over in Newfoundland, the weather in Newfoundland makes the weather in Hobart look positively balmy. This was winter in Newfoundland, snow, gales, blizzards, you name it. They tried using a balloon. They ended up putting a kite up and got a wire up, tuned it, and they used a newly developed coherer, a coherer. It's a ball of mercury between some iron and a carbon rod. I think it was developed by the Italian Navy. An advantage of the mercury coherer is you don't actually need to mechanically decohere it. When the signal disappears, it will restore itself after a fraction of a second. So I used a pair of headphones in series, and they telegraphed instructions back to the transmitter to set on a certain schedule to transmit a series of S's. Dit, dit, dit. because all they would have heard was the beginning of the character on the headphones, and what they were listening for, if I can get this to go, was together with lots of other clicks. Now, Marconi reckoned he heard it.
In December 1901, Marconi was with his assistants Percy Paget and George Kemp in Newfoundland. Percy Paget told the story in a radio broadcast 30 years later. This is Signal Hill, Newfoundland. It's on a headland of the harbour leading into St John's, Newfoundland. On top of the headland is what's called the Cabot Tower. That's as it is now. And in 1901, there is Marconi's crew on Signal Hill. Marconi's assistant Percy Paget tells the story himself.
Not a shrub or a tree, only a deserted military hospital, in one room of which Mr. Marconi set up his apparatus. We had brought 2 15-foot balloons and 6 kites for the purpose of elevating the aerial, but the weather was terrible, and for a couple of days we battled with the elements. One of the balloons being carried away by the gale, which snapped the heavy mooring rope like a piece of cotton. We managed to fly a kite up to 400 feet. It flew out over the stormy Atlantic, surging up and down in the gale and tugging at its 600 feet of aerial wire. The icy rain slashed my face as I watched anxiously. The wind howled around the building, where in a small dark room furnished with a table, 1 chair and some packing cases, Mr. Kemp sat at the simple receiving set while Mr. Marconi drank a cup of cocoa before taking his turn at listening for the signals which were being transmitted from Pole Due.
Marconi and Kemp recount the events of 12th December 1901 in a reenactment 30 years later.
I placed a single earphone to my ear and started listening. The receiver on the table before me was very crude. A few coils and condensers and a coherer. No valves, no amplifiers, not even a crystal. Listen to this, Kemp. Take the headphone. Can you hear anything?
Yes, there it is.
The letter S?
Distinctly, Mr. Marconi. Paget, come here and listen.
The result meant much more to me than the mere successful realization of an experiment. It was an epoch in history. I now felt for the first time absolutely certain that the day would come when mankind could be able to send messages without wires, not only across the Atlantic, but between the furthermost ends of the earth.
Together with lots of other clicks. Now, Marconi reckoned he heard it for about 15 minutes, and he gave the headphones to George Kemp, his assistant, and he reckoned he heard it. A lot of people didn't believe him, but 3 groups of people did. One was the Anglo-American Telegraph Company, who promptly served him with an injunction to stop because he was in violation of their monopoly with the Newfoundland government. They had a telegraph monopoly. The second was the Canadian government. And when he gave up, he didn't want to get involved, he packed up his gear, headed off to Nova Scotia, took the ship to Nova Scotia, landed in Nova Scotia, and there to greet him were 2 very senior Canadian politicians who offered him land and $80,000.
Whoa!
Which was a lot of money in those days. Canadian dollars, I'm sure they were worth quite a bit of money too. They wanted to get one up on the Newfies because Newfoundland up until 1948 was not part of Canada. They wanted to break the Newfies monopoly too. And the third group of people was a lot of very wealthy New York businessmen, because he went down to New York for Christmas and they were really delighted to have the chance to break the cable monopoly. You think bandwidth was a problem now? Then it was limited to about a total of about 50 words a minute, because the submarine cables could only handle about 10, 12 words a minute. The later ones they worked out how to get faster characters down submarine cables, but They were pretty slow, and there was just this incredible demand for telegraphic communication. The alternative was a letter that took about 3 weeks to get there. But, there was a breakthrough in 1902. Marconi started building his station in 1902 at Nova Scotia, but he made one great discovery, the magnetic detector. Now, this is a genuine, very early one, courtesy of Rex, and this is one of the sort of later production models, and this is the second one I've ever seen. The first one I saw about 3 weeks ago in the Museum of Transport and Technology in Auckland, because the principle was developed by a clever little Kiwi called Ernest Rutherford, who went on to split atoms later on in his career. And the Kiwis are rather proud of him, and another bloke called Ed Hillary, I think. It was a brilliant breakthrough. It was about 100 times more sensitive than a coherer. It could actually detect signals down in the millivolt level. You could hear the signals, and it'll actually decode phone amplitude modulated telephony as well. You can use it as a broadcast receiver. It was almost indestructible. And basically the way it works, I don't know whether I've got, this isn't quite the one I was going to, the way it works, as you can see here, there's two magnets, and they're actually polarised with these two poles the same and these two poles are the other. There's a wire, a very fine braided soft iron wire that goes round and round at about 1 to 200 millimetres a second, and as it goes past here, it's polarised in one direction and it saturates in a very low magnetic field. And as it goes through the middle here, the field is reversed as it gets into other. And because of the hysteresis, is a flip, and that flip introduces a very weak DC current in the centre terminals. So essentially, you get a weak DC current flowing through here. If there's any RF flowing down through the inner solenoid, the little tiny one, that's missing on this one. There's a small solenoid which had the connect between the aerial and earth terminals. Then that partly demagnetized the wire, so the current here was negatively modulated by the amplitude of the RF. Really, really simple. The only way you could damage one was break the wire or put a battery straight across the terminals and burn the wire out. They were literally indestructible. And they were driven by a clockwork motor. You can see the handle on here to wind it up. And they became the workhorse of the Marconi system for the next 10 years, up until 1912. And they stayed in service till about 1916. And about 1905, people started discovering there were various minerals that had rectification properties. Most of you have probably heard of the crystal set. Yes, I think even the younger blokes probably heard of crystal sets. I've never actually used a cat's whisker, but a galena piece of phosphor bronze wire, a bit of piano wire pressed against a galena crystal, you could find a spot where it would rectify. When it worked, it was great. Finding that spot was the hard part. And I believe that families would sit round listening to the concert and someone would come in and slam the door. And father would say something that's not repeatable, and they have to spend ages trying to find the sweet spot on the crystal again. Very sensitive, but bloody twitchy. Amateurs loved them, but they were never used commercially because on board a ship or something, you wouldn't know whether there was no signal or the thing wasn't working. You had to have reliability. Another material that was quite good was corundum. You had to bias that, so basically it's just a nonlinear conductor you'd bias somewhere about here, and any nonlinear conductor will rectify or mix. It was used on board ships as a backup. It was used on some of the little trench radios during the First World War as the detector because it was so rugged. Deaf as a post, but it worked. And of course, about 1905, Fleming, who was Marconi's engineer, revived an old idea of Edison's and of putting a plate inside a lamp. Current would flow one way and not the other. He took out a patent that he uses as a rectifier, but it took about another 5 or 6 years before they could find the right combination of materials for a filament that would emit electrons well and be rugged enough to... The early diodes had lifetimes of the order of hours, and the slightest vibration will wreck them. I think the first one used tantalum for the filaments. Carbon didn't work, and it took a while for things like thoriated tungsten and all that to be developed. But of course, ultimately, they worked out they could stick another electrode in and make an amplifier out of it, and that changed the game completely. But that wasn't going to happen for another few years yet. So there's a problem. Once you've got a detector that actually can listen to the signal, you want to get this pulse rate up. For a coherer, it didn't matter. As long as there was a spark about 5 times a second, you didn't need a second spark until the coherer had a chance to tap the tapper had a chance to clear the coherer, and then you could fire it again. But for audible reception, you wanted a high spark rate. You got a higher average power, which meant more volume. Your ear is much more sensitive to notes around sort of somewhere between about 300 hertz and about 1 kilohertz. You can pick that up easily out against the background noise. And of course, every transmitter is going to have a slightly different tone. So you can, if you're getting interference, you can listen to the ones just as you can listen to an orchestra. So listen to the trumpets and not the violins, or vice versa, or the pianos. Inter-ear processing is very, very valuable. And only problem is that when you start raising the pulse rate, you have a problem. When your spark stops, you've got all these iron products floating around. You've got to clear them before the voltage starts charging up again, or otherwise you get a premature discharge. And you get a very ragged spark and pretty inefficient operation. Now, for a lot of work, the most popular method was to use a rotary spark gap. This is one of Fessenden's high-powered gaps, and basically the gap is between there and there, and this is just a great ring full of knobs. So they come in, just as the voltage is reaching its peak, they line up, you get your arc, it's stripped away, and then by the time the next pulse comes, the next one's there. I believe, in fact, Fessenden actually got spark rates up to about 10 kilohertz, and he actually used a DC, about 10 kV DC, and the sparks were just fine rather than using an AC feed and a transformer. What was far more common was the disc type rotary gap, but you had to have, the motor had to be synchronised to the power supply, because of course if the gap's lined up outside the peak voltage, you didn't get much effect at all, and if they weren't synchronised, you got a tremendous amount of QSB on your signal, and it wasn't all that effective. And here is a replica of a 0.5 kilowatt spark transmitter, rotary gap. You'll notice the capacitors, 6 wine bottles, copper sheath. It looks like, I think they're filled with copper sulfate solution. A wet capacitor. Works all right. You'll notice all the connections are made with copper strap, and the reason for that is, well, partly it looks flash, but more openly, the currents involved are very high. You're talking of currents of 300 or 400 amps. It's you're discharging several kV into almost a dead short in a few microseconds. Some pretty fast currents, and so that excites the primary transformer, and there's your secondary transformer. And I think I can. And you'll notice here there's a set of secondary spark gaps. That's in case the spark gap here fires. They fire to stop the transformer burning out. They're sacrificial. I wouldn't actually want to be standing next to one of those if I had a pacemaker. I think some of the pulses around could cause a bit of fun and games. Yeah, if I click off again. So basically, by about 1903, the spark technology was fairly mature, and both Telefunken and Marconi and a couple of smaller companies started building spark transmitters all around the world. They almost all operated on long wave. That's wavelengths below 300 kilohertz. And the reason for that is the longer the wavelength, the more reliable the propagation is. The noise level's pretty high, but the Maggie, as long as the Maggie could detect the background noise, so you really no point in having it much more sensitive. Most of them were about 2 to 10 kilowatts. Some of the big Marconi stations were up to Marconi did go to half a megawatt at one stage, but he stopped at about 150 kilowatts. At half a megawatt, he had massive problems with corona discharge off the aerials. When you consider the peak voltages involved, I believe you could actually read the Morse from the glow from the aerials. And you could hear the actual arcs a couple of miles away. You could read the signal. And I believe that there was a station in Melbourne, and when it was transmitting, you could draw sparks off the railings of the domain. That's the sort of currents that are involved. It's quite horrendous. This is a picture of a telephone station that was installed in the then German colony of Samoa. It was taken over by the Kiwis early in the Second World War. And the reason I've included this is that one of the young engineers that was sent across to get it going again, because the German engineers had tried to wreck the station before they surrendered, was a young fellow by the name of Casey Harris, ZL4CA, and he was my first contact in New Zealand in 1971. So he told me a lot of stories about the early days of Spark. Long since gone these days, but he was a hell of a nice chap. And on the other extreme was the Cape Breton near Nova Scotia. And in 1902, he was running on about 180 kilohertz. The aerial was basically 4 wooden lattice towers each, I think was 60 metres high, with the Marconi loved big inverted pyramids or cones for aerials. That's actually drawing of the one from Poulsen. He ran about 20 kilowatts, and he realised he could only get reliable communications about 8 hours a day. So in 1905 he realised the propagation was better to Ireland, so he built a station in Clifton in Ireland. And that ran on 82 kilohertz, 50 kilowatts. Increase the wavelength, increase the power, more volts equal more volts. In 1907 he dropped it even lower and went up to 75 kilohertz. And in 1913 he set up a duplex link, and it went over at 37.5 kilohertz and came back, I think, at 50 kilohertz. His receiving station was, I think, at a place called Louisbourg, about 40 kilometres away, and linked by telegraph. And at that stage, I think he actually at one stage tried the half megawatt, but then settled on 150 kilowatts. And the interesting thing is, at that point, he was actually running high-speed CW. He was running a spark rate, I think, of 750 a second. And he was using 15 kV DC on the spark, on a rotary gap. And to receive it, they actually, it came in, it was too fast for someone to read. It was done about 60 words a minute. They put it through a carbon button amplifier, a so-called ground relay, into a dictaphone, and they had its banks of cylinders, and they recorded on a dictaphone cylinder, and every 3 minutes someone was changing his banks. They were then taken off and played back at half speed to be transcribed. This was the way to get just the sheer volume of traffic. It was sent by machine code. It was punched onto Pate's tape, but the stuff coming back was too fast and they recorded it and played it back at slow speed, all on mechanical graphs. And that basically stayed in service till about 1925. No, about 90, yeah, I think they shut it down. By that stage they discovered short waves. Those wavelengths that the amateurs could have, everything below 200 metres, we don't want it. It's useless. Well, suddenly guess what they did. But that's another story. And I promised to talk about the Titanic. Everyone wants to talk about the Titanic. There's more conspiracy theories of the Titanic than there are about the moon landings. This is a typical ship installation in 1912. This is the Marconi room of the Olympic, which was a sister ship to the Titanic. And you'll notice a standard old tuner, which tuned from 200 metres out down to 10,000 metres. That's 30 kilohertz to about 1.5 megs. A magnetic detector, and then the newfangled diode detector. It had 2 diodes in because in case one blew, you could switch over. They were only used when you really needed them. You didn't use them in heavy seas or anything because the filaments wouldn't have taken the vibration. The transmitter was in another room. It was typically a motor generator set. Ships ran on about 100 volts DC, and that generated about 240, 300 volts AC at around 100, 150, 300 kilohertz to give a good tone pitch. And these are all the controls here for it. It had to be in another room because the radio room had to be kept quiet. Because the operators had no amplification, they had to hear very weak signals in their headphones, and their hearing was their greatest asset. And the other thing was that Marconi never sold the equipment, he only leased it. He leased the operators, all the wireless operators were Marconi staff. They got paid by the shipping company, but they weren't subject to the ship's cruise regulations. They were external contractors. They had their own uniforms, and one of their major sources of revenue was passenger telegrams. It cost 12 and 6 for the first 10 words, and 9p a word thereafter. That doesn't seem much, $1.25 for a telegram. Well, 12 and 6 was something like the average weekly wage of a clerk in the City of London. So, but for the first class passengers, well, they'd probably drop 50 quid a night on the gambling tables and not notice it. Sounds a bit like modern times and politicians at times, but it was very much a commercial operation. And passenger telegrams are really important. And when it comes to the Titanic, this is the only known picture of the Titanic's Marconi room. It was obviously a bit of camera shake because you can see the double exposure. It was taken by a Father Brown who got off at Queenstown and went on to become a famous fictional detective. No, only kidding. But it was actually Father Brown who got off at Queenstown, and the only pictures of the Titanic are what he took. The radio aerial was strung, a T strung between the mast. The wireless office was up on the top deck. And of course the earth was the steel hull of the ship sitting in seawater, pretty good earth. Now the range of the equipment on the Titanic was nominally about 500 miles. Whether nautical miles or real miles, I'm not quite sure. But when they were about 700 miles out from Cape Race, they got within range, and they had about 300 telegrams waiting to be sent. And they were sending telegrams solid for 2 hours. And while they were sending the telegrams, there's a rather cheeky wireless operator on a ship called the Californian, about 40 miles ahead of them, sent out a general call to all ships in the vicinity giving his location and advising they were stopped in the water due to heavy ice. The reply from the operator at the Titanic, as recorded in the inquest, says, "Shut up, we're working Cape Race." Translated, "Piss off, we're busy." And it got noted in the book. They wrote it onto a piece of paper, put it in the basket for the messenger to take up with the captain sometime. The operator of the Californian, it was 11:30 at night. He said, "Well, there's nothing much for me." He turned it off and went to bed. There was only one operator. There was nothing happening, he went to bed. An hour later, guess what happened? So the one person who could have helped the Titanic was no longer there. And it's interesting that when this is actually a reconstruction of one of the last transmissions from the Titanic, and I put it in because it'll show you what a rotary gap transmitter would have sounded like.
It's a CQD, old man. DMGY, Titanic's call sign. Position 4146 north. (5014 west). Sinking. Cannot hear for noise of steam. DMGY CQD SOS CQD.
You'll noticed that they were using two distress calls, the old CQD, which is a company call, and this new SOS, which had come in a couple of years earlier. But Marconi Company was incredibly hidebound. They didn't change anything. In fact, in the early days, the British government had to actually pass a law requiring Marconi stations to talk to ships that weren't carrying their equipment. He really did try and tie it up. There was a hell of a lot of confusion in the radio spectrum, because there were no real procedures for handling distress calls, and the fact that they used a call that half the people didn't recognise it as a distress call. And if you read the transcripts, people come back and say, "Are you in trouble, OM? Yes, please, we're sinking. Do you need any help? Yes, please. Roger." And one message said, "Have lit another boiler proceeding at full speed," but they were about 120 mile away. They got there about 5 hours later, about 3 hours after the Titanic had sunk, and those who weren't in the lifeboats were dead of hypothermia if they hadn't drowned. There was a major shake-up of maritime rules and regulations after that. But like every disaster, it's not one single event. Yes, the ship hit the iceberg. It was steaming at full throttle in the middle of the night. A captain who wanted to set a new speed record, to hell with it. Wireless operators who were too busy to pass the message on. Yes, radio did actually play a part in the sinking of the Titanic, and it probably could have prevented it if the message had got up. Whether the captain would have taken any notice of it is another matter. But he went down with the ship, so no one will ever know. But if you're really interested, there's a whole lot on the tube, together with all sorts of conspiracy theories of how it was deliberately sunk, and it wasn't really the Titanic, and it was an insurance fraud, and you name it. And the Earth fraud as well. So I don't want that.
I'll just interrupt that there to say this is VK3 Alpha Mike Lima with a regular Saturday night test transmission, currently transmitting a lecture by Mike Groth VK7MJ on radio history from Maxwell to Marconi, a history of the period of radio before electronic amplification, and we're currently talking about the Titanic. Back to Mike.
Spark was also used. Fessenden was very interested in trying to use spark for transmitting speech, and he actually built a spark transmitter with a park rate up to 10 kilohertz, and he used a carbon microphone in series with the Earthlead, because there was no other way of modulating systems. There were no modulators. And he made carbon microphones that would handle 8 amps of DC, 8 amps of RF. They were water-cooled, and apparently they were big blocks. They had a giant corn on them, like the acoustic recording of gramophone records. And this, a lot of his work's been researched by a group in Canada in the Communications Research Centre, and this is a recreation of one of his systems as received on a crystal set.
Hello, 1, 2, 3, 4. Is it snowing where you are, Mr. Beaton? If it is, telegraph back and let me know.
You can pick up a bit of it. Not a particularly good medium. What he was receiving the detecting with, I don't know. I suspect it was an electrolytic detector, because Fessenden built a very good electrolytic detector. It used a platinum cup full of sulfuric acid and a platinum wire dipped into it, and you biased it at the point where it would just start to conduct electricity, and at that point electricity would flow with the current rather than against the current. It's exactly the same sort of thing as like a mercury arc rectifier. Electrons travel much faster than the mercury ions. And that in its day was actually the most sensitive detector there was, but it wasn't particularly practical. You didn't want this flopping around on a ship's radio bench or anything, but it was a lab type detector. So spark and phone never really, spark was really a telegraphy medium. But it was the method for about 10 years, was all international communications were done with spark. Now, I've been talking for an hour. Do you want me to go on and talk about these?
Yes, please.
Yes, okay. There was a move. People wanted to find a way of generating CW, a continuous wave. And before the development of electronics, there were two methods. From about 1905, there was the high-frequency alternator. And that's just basically an alternator like it's in your car or the hydro have out here, with lots of poles spinning at high speed. Some of them got up to 20,000 RPM, and I believe when bearings failed, the results were quite spectacular. I believe several experimenters had to, when they fired them up, had a good place to duck for cover before shrapnels headed everywhere. And then there was the Poulsen arc converter. That was a fairly short-lived technology, thank goodness, from about 1910 to around about 1920. In the high-frequency alternator, there were three designs. One was basically like a multi-pole version of the standard old power generator, and that generated an audio frequency. You put that into a saturating transformer, which effectively generated a square wave. You tuned the secondary for 3 times the frequency. You could do that twice if you wanted, but each time you only got about 70% of the power in you put out that you put in. And anyone who's worked with saturating transformers know they get damn hot. If you've ever worked with constant voltage transformer systems, they do. You've got to put things like concrete blocks underneath them, or they cook the lino underneath them. I can tell you that from our field stations when I used to work with the EPA. The fellow Goldsmith in Germany, he came up with a rather cunning design by using the rotor of a generator, and he put a very high permeability material in so it's saturated, and he could make it operate at its second or its fourth harmonic with considerably reduced efficiency, but it worked. But one of the most successful was the alternator developed by Fessenden and Alexanderson. Fessenden actually developed it, but Alexanderson was the engineer who made it work. That would actually generate up to 100 kilohertz directly, and they were very successful. They were limited to very long waves, VLF or LF. You could get up to a couple of 100 kilohertz with fundamental generation, but basically below 100 kilohertz. They generated pure CW. The frequency just depended on how fast you spun them. And they were only ever used on shore-based stations, only used on ships, considering the effect of a large rotating high-speed mass in a ship and the rolling of the ship. I'm not sure which would have given up first, the bearings or the mountings, but it certainly would not have been a very reliable bit of instrumentation. The simplest thing was the audio frequency alternator with the multipliers, and so basically you generated something between about 3 and 10 kilohertz, multiplied it up. Now there was one jet built in 1929, installed in 29 in Yasami Radio in Japan for the Imperial Japanese Navy, and that had a 1 megawatt DC motor running a 700 kilowatt alternator with 256 poles, not your 8 poles or your 16 poles of your typical power alternator. That generated a 5.8 kilohertz signal, tripled it with a saturating transformer, and fed half a megawatt into the aerial, and probably radiated about 2 kilowatts if they were lucky. But then again, 2 kilowatts of those frequencies, any ship anywhere in the world would be able to receive it. The Goldschmidt alternator basically used a high permeability iron rotor. Now, they were very difficult machines to build because the rotor had to be made of laminations of basically mu metal or permalloy, or one of those very, very high permeability irons, less than 0.5 millimetre thick, each with a spacer in between. There had to be less than 0.5 millimetre gaps between the rotor and the stator. That's a picture of a 12.5 kilowatt Goldschmidt alternator at Eberswald, I presume that's how it's pronounced. My German isn't all that good. I'll probably be corrected sometime or other. But basically, here's your DC motor. A gearbox usually about 5 or 6 to 1, spinning the alternator. I think these are probably cables carrying water cooling for the stator, and that's probably feeding air down to keep the rotor cool. Because when it's running in harmonics, you're going to be dissipating 30% of your energy just as heat in the magnetic core. And they are bloody hard things to cool. They did make them up as far as 100 kilowatts. One was installed in Ellerfeis in Germany, and apparently during the First World War was the main link between Germany and the rest of the world, because the Royal Navy cut all the cables linking Germany with all the rest of the world. and everything in and out of Germany had to go on long-wave telegraphy. Another one was installed in Tuckerton, just over the river from New York, and it went into operation about 1914. The US Navy promptly took it over when war was declared, the 240-metre tower, typical Telefunken design, it was put in by Telefunken, a big single vertical. The tower was still there in the 1950s. I think they knocked it down in the late 50s. By that stage it was no longer the tallest structure in North America. Things like the Empire State Building had taken over, and I think the Chrysler Building in New York was probably taller too. And the Fessenden Alexanderson alternator, this is his first alternator. It was driven by a flat belt from a steam engine. There's the gearbox, and that's the alternator. It has no rotor winding at all. It's a magnetic chopper. And this is one of his later ones. There's the electric motor, the gearbox and the alternator. And, essentially the rotor is just a disc of transformer grade steel, and it has a whole pile of slots cut in. Now, because of all the effects of having a pile of slots going through them, you'd act like a giant siren. They were filled in with brass or, I believe, gunmetal, something that's not ferromagnetic. And it had 300 windings of a coil, 300 with a gap in the middle of a core, and the gap was alternately either had a piece of iron in the middle which completed the magnetic circuit, or a piece of brass in the middle which broke the magnetic circuit. So what you were doing, even though the field current there was staying constant, you were opening and shutting the magnetic circuit several hundred, 1,000 times a second, and that was picked up there. It was a very, very simple design. It didn't. And you could actually modulate it either by keying the 110 volt supply, or they used a thing called a magnetic amplifier, which was actually a saturable reactor, which connected or disconnected the system to the aerial, basically an aerial switching system. I'll double it again. That is the last remaining serviceable Alexanderson alternator, which is at Grimeton Radio in Sweden. It produces 200 kilowatts at 17.2 kilohertz. There's your motor, your gearbox and the alternator. In the background is actually the magnetic amplifier, and they're the feed lines to the aerial. That's actually still operational. It was probably the most popular of the alternators. It was Fessenden really was a brilliant designer, and Alexanderson knew how to make them last, because it's been in service now for close on 100 years. But the problem was, how do you detect the CW signal when all your detectors are amplitude detectors? Well, Fessenden came up with the idea of a heterodyne detector. Smart little fella he was. And in this particular design he used actually an oscillating arc as the local oscillator, so you'd run at about a kilohertz different from your frequency. He used an electrolytic detector because that's what he had back in 1902, and a pair of headphones. It also, if you were running it realistically, if you were running a duplex telegraph link, you send and receive signals. If you made them about a kilohertz apart, you'd use your transmitter as your local oscillator for your receiver. Mix them together. You don't need any amplifiers, you just need some sort of nonlinear conductor, and a crystal worked well. Guess what? Some radio amateur has worked out how to do the whole thing with no electronics at all. He used a stepper motor driven by a DC motor to generate 8 kilohertz, and of course the stepper motor has two coils basically 90 degrees out of phase, so he's feeding 8 kilohertz signals, 90 degrees phase difference. He's resonating these ferrite rings at that frequency, so these saturate twice each cycle, and they unsaturate. And because they're 90 degrees out of phase, alternately 16,000 times, 17,000 times, 16,000 times a second, this turns on, and then this turns on, and because they've been wound in counter phase, it doesn't actually generate any local signal. And so it's a nice, completely non-electronic receiver. Why? Because he could. And he actually used it to receive the Grimeton radio. But so you can actually do it with no electronics at all. Fessenden was actually broadcast speech and music from Brant Rock. He used, with his first rig, which is a 500 watt alternator on 75 kilohertz, and he did a Christmas Eve broadcast. He played some music and read some Christmas stories and all the rest of it, and it got heard away as far as Norfolk in Virginia, which I think was probably a couple of 100 miles. And he did a second one on New Year's Eve, which was heard in the Caribbean. And I believe when he was setting up for it, he got a letter a few months later from Scotland describing what was going on in the studio. There was someone in Scotland listening to it. He must have just had freak conditions. For about 10 minutes, someone in Scotland actually heard it as well. So that's actually considered to be the world's first wireless broadcast in 1905. But done with a big carbon microphone, a very big carbon microphone. And the last method was the Poulsen arc converter. That was basically, back when they used arc lamps for street lighting, they would discover sometimes they would start singing, making a noise. They were fed from 600 volt DC, which was the voltage they used from the trams and the trolley buses and all the lifts and that and buildings. It was the standard sort of industrial DC supply voltage. But they'd start singing, and a fellow called Duddle had a look at it, and he realised that you could get a resonance in them. If you put a series tune circuit across a spark, an arc, it would actually the thing would actually oscillate. A fellow by the name of Poulsen was playing with one of these things. He put an alcohol burner under the arc, and lo and behold, he managed to get it up into about 200 kilohertz. Normally, in air, it'll only work at audio frequencies. Very difficult to key. You've got to strike an arc and maintain it. You can't turn it on and off it quickly. So what they did, they either shorted out part of the loading coil, so it had a frequency shift keying. About 20 or 30% difference in frequency. You can imagine what that made friends on the air, didn't you? Or they had a very elaborate system to switch from the aerial to a dummy load. But the big problem is the leakage from the system meant you usually had to have a separate receiving station somewhere. They weren't, and they were filthy waveform. If you were on 50 kilohertz, it left a 50 kilohertz every 50 kilohertz all the way up to about 30 megs. It made television line oscillator output interference seem really benign. Thank goodness they didn't stay long. And basically, very simply, an electric arc has a negative resistance. As the current rises, the voltage falls. And if the negative resistance is greater than the positive resistance of the system, it becomes unstable. You stick a series tune circuit across it, and that takes control of the situation, and it oscillates. And yes, Duddle's singing arc only works in audio frequencies, but sticking basically a hydrogen-rich atmosphere. Hydrogen ions are very light, so it'll operate at a much higher frequency. And that's what they typically look like. One way to think of it, the current flows down through the anode, the cathode, round through the electromagnet and back out. Why the electromagnet? Well, as the current's flowing, the plasma's flowing through, it's flowing across a magnetic field. What's that going to try and do? It's going to try and kick it out of the way. It's going to act like a buzzer. So think of it as a plasma buzzer. And the plasma is the armature of the buzzer. And the aerial inductance and the capacitance of the system set the resonant frequency. And yes, that's how they used to key it, short out part of the system. After the First World War and radio usage started improving, they banned it. They banned frequency shift keying for fairly obvious reasons. It just took up too much spectrum space. That was a typical installation. It was being very much promoted in about 1910 as the answer to everything. It was the future for radio. Forget alternators, they were too complex. spark was obsolete. This was the way to go. It was the answer to the maiden's prayer or whatever, you know, best thing since sliced bread and canned beer. And they were big. A 1 megawatt unit built for the US Navy by the Federal Telegraph Company, founded by DeForest, the man who invented the triode valve. They used to put smaller units on ships, but they had one big problem. The sailors drank all the alcohol. Because US ships are dry, and you know what sailors and alcohol are like. They don't drink anything that with alcohol in. They apparently had to resort to some very exotic alcohols that were literally undrinkable to keep them going. And of course, yes, some radio amateur has built one. I wouldn't want to be near him if he used it. He did comment that all the valves and the flaps on the combustion chamber were made of rubber because you did get an explosion when you started it up. First started dripping alcohol into it. And it was used for telephony, but the same problem. It was quite good for telephony because it was a CW, even though it was a filthy waveform. People got, in 1910, a fellow by Elwell wrote a paper promoting it, and he claimed that it had been used for trials over up to 500 kilometres, using a carbon microphone coupled into the aerial circuit. A similar technique was used in the 1930s for people who couldn't afford modulators. They used to call it loop modulation. You'd make yourself a CW transmitter and you'd stick a carbon microphone inductively coupled into the aerial circuit. The poor man's telephony. Well, by 1914, the world changed rather dramatically. The First World War came along. But electronically, by 1914, the vacuum technology had been developed to the point where they were now commercially available. And they were practical alternatives to the spark technologies. The real advantage was that the triode, once they put the electrical electrode in, you had a triode. You could amplify. You could have oscillators. You could have modulators. You could have all the things that we now think of as radio were possible. And of course, by the end of the war, spark was dead in the water virtually. And from the 1920s came along, then of course broadcasting and everything was valve-based. Spark basically, by 1920, the great Cape Breton installation was all valves. Marconi got out of spark very fast. It was not only were the valves far more efficient, they made much better results with valves than giant. You didn't need. I think they ran aerial currents with the valves of something like 300 amps into the system. They did similar thing in rugby. A great big VLF transmitter in rugby ran about that sort of thing. Spark was officially going to be outlawed in 1927 at the ITU conference from 1930 and completely gone by 1940. The Second World War intervened in 1939 because they hadn't quite sorted out the mess from the first one. And a lot of ships carried backups, spark transmitters as the ultimate backup in an emergency. And Casey Harris told me of receiving a call in 1942 from a ship that had hit a mine somewhere off in the Pacific, off the coast of New Zealand, and they were taking to the lifeboats. The ship was sinking. And the interesting thing is that the operator in the monitoring station was ignoring it. He was walking past, he heard it over the loudspeaker, walked in, and said to the operator, translated, "Excuse me, why are you ignoring that distress call?" What distress call? Because the operator had never heard a spark transmitter. They were so hard to, they just sounded like interference. Casey said, "Shift your backside off that chair, please," and sat down and copied it because he'd grown up with spark and duly dispatched a ship out to pick up the survivors, and I think all ended well. So spark was definitely in use in 1942, but on the amateur bands it basically disappeared from about 1924. Spark was really a long wave thing where you had high Q aerials. On HF you really couldn't tune a spark transmitter to any narrow bandwidth, and you didn't make any friends using one. It all went valve. Poulsen arc converters, thank goodness, were phased out in the 1920s. I think the Royal Navy kept one going somewhere near Portsmouth until about 1930, and I think it put a harmonic every 45 kilohertz all the way up the band, and when it went off, every radio amateur in the southern England breathed a sigh of relief. HF alternators actually hung on for a long time. There were a lot of long VLF telegraph systems, and the system, they ran. If you kept them, if you maintained them, they ran. So why rip them out and replace them with something else? Basically up until the 1950s. There were about 32 of them in service in the 1930s, mainly I think Alexanderson, Fessenden alternators. And they got a new lease of life after the war when they realised you can talk to a submarine using VLF, and they only have to come up to periscope height, and they can receive the signal up to about 10 metres underwater because of the skin depth at those frequencies. And so the Asami radio transmitter in Japan was kept in service for the US Navy until 1993, and Grimeton radio until 1996 for submarine communications. The Asami radio is now a museum. Grimeton radio is still operational, and they fire it up at least once a year, though because New Year's Day this year occurred on a Sunday, they fired it up on New Year's Day. At least I think they did, it was scheduled to. I wasn't listening, so I wouldn't know. And that's about it. That's the radio in the days before electronics, when it really was stick, string, single wax, sealing wax and a few sparks.
And this is VK3AML with the regular Saturday night test transmission. Apologies for the audio from this, but it was recorded on a video recorder across the room from Mike. I've done my best to bring up the intelligibility of his voice, but he was battling an air-conditioned heater in the rooms at that time, in the meeting rooms of the Radio and Electronics Association of Southern Tasmania. I'll just conclude with Mike's final demo of the magnetic detector and spark transmitter, small spark transmitter he had at the rooms that night, and in 7 minutes we'll open up for a QSO on 147.475. That'll be around about 4 minutes past 11. Back to Mike and question time for his lecture, Radio History, Maxwell to Marconi.
Can you demonstrate your transmitter?
I will try. I've had a few problems. I think I've got a breakdown in the high voltage side of the thing. Essentially, it was a car ignition coil that I pulled apart, discovered they were full of nasty oils, and by the time I drained everything out, and I put it in here and I built a trembler mechanism for it and filled it up with wax. But I do have a problem. I'll see if I can get it to go. That's running as a trembler, actually using the magnetic field to interrupt the circuit. If I turn the radio on, someone likes to take that. I should hear it from there. It's been tuned to about 1.8 kilohertz. The spark is really rapid. But you see, it's not easy to detect against background noise.
Yeah.
So one of the advantages of a rotary gap was you can... I'll try and get the thing to work. Should give us a... You get a much...
Yeah, very different.
Yeah, that's about 500 sparks a second.
Yeah, okay.
So you can pick that out. That's why they went to rotary gaps, because it gave you a tone that was much easier to pick out compared to... what's going on there? Compared to that.
Yeah.
And the signal you used to hear was... Did-a-did-a-did is the actual official signal for I'm adjusting my spark. If you look at the old books, you'll find that, the 4 adjustment signal. Not the V's, but the did-a-did-a-did, did-a-did-a-did, did-a-did-a-did. That was meant you were tuning your spark, and you had to tune your spark. You wanted it really short, fat and hot. If you didn't have your gap just right, you got a ragged spark, and you didn't get a good note, and it wasn't as easy to read or get a nice power. There was an art to tuning spark. I wouldn't know how to do it. But yes, it didn't work as well, and I do have a problem with it, with breakdown in it. What's far more successful is to make a chopper and use an ignition coil. I did put a high voltage transistor in there because I discovered very quickly that a piece of brass is no good for as an interrupter contact. It runs for about 30 seconds and it's so pitted and corroded, you've got to get out a file and file it up again. So I put a switching transistor. I pulled an old electric fence apart. That's where the coil came from about 40 years ago. The capacitor's about 270 PF. It's just a jam jar wrapped in. If you want a high voltage capacitor, a jam jar is good for about 200 PF. I did make one with some glass plates. It was about a bit over a nanofarad and filled it all up with wax and everything. But this coil just can't produce enough power to charge it up properly. If I was connected to a neon transformer or something like that, and I'm not really interested in going there.
It's one of them up at the resource tip shop, but anyway.
Well, maybe.
10 kV out.
They used to have one in the University of Adelaide that ran a Tesla coil, which that was about a 500 watt spark transmitter from an old ship. And when they used to fire that straight off the 240 volt mains at about 200 amps or something, it used to blank out radio communications in Adelaide. They used to do it once a year, and they made arrangements at the post office first to let people know it was going to happen. So the RIs didn't get too hot and bothered. But about once a year they'd do a demonstration for about 5 minutes to the first year students. It was pretty spectacular with all these bolts of lightning flying across the lecture theatre. And I'd like to thank Rex for bringing along his dad's old Maggie. That's only the second one I've seen, and I think that's a very early model. It'd be fantastic if you get it going again. But the biggest problem is trying to make the fine iron wire for them, because all the strands had to be insulated. It was a bit like Litz wire, except it was made with iron and it tends to rust, so it's limited. It would be about 80 or 90 years old, wouldn't it? Or close to
more than that.
Yeah, it'd be close to 100. That would be at least 100, because they went out of service in 1916, 100 years ago, so that's probably 100
Based on the
years old.
serial numbers and the history, I made it about 1903.
Yeah, I can believe that.
In which case it's well over 100
they
years.
came into service in 1902. Yep, that'd be about right. Right.
Do you know where it came from, Rex? Where it was actually used?
No. The story is interesting in as much as as a little kid, about 10 years old, I found the thing up in the roof. And I asked my dad, and he says, "Oh, look, someone gave it to me because I was a little kid interested in radio, and there was this old obsolete radio."
Okay.
Now, unfortunately, what I did is I noticed there was these wheels on it, which were good for billy carts, so they're not the original wheels. There was a terminal strip on it, which I used for crystal set or something at a later stage, so that's not the original terminal strip.
Well, they should do.
But
Exactly.
with obsolete things. It's only since I sort of later realised the historic value of it all that I so regret that I didn't leave it as it was.
Any more questions for Mike?
Well, I sent them all to sleep where I baffled them with the bullshit.
Wonderful bullshit.
Can we show appreciation?
And that was Mike Groth VK7MJ with the lecture Radio History Maxwell to Marconi, 1864 to 1914. It was originally delivered on the 8th of February 2017, and with Mike's assistance we've put together a slightly more visibly intelligible version of that from Mike's PowerPoint, other illustrations that have become available since 2017, and some audio illustrations which I was aware of, namely the recollections of Paget and Marconi from their 1901 sojourn on top of that incredibly barren Signal Hill just outside St John's in Newfoundland, doing the first transatlantic test, which resulted in success on the 12th of December 1901. This is VK3 Alpha Mike Lima. If you want to look in on the video aspect of this, we're live streaming at the same time that we're transmitting on 147.475, and shortly we'll open for a QSO, hopefully, if anybody's still out there. We had a false start on the live stream tonight, so if you see two live streams with 11th June 2022 written on them, one will have about 3 minutes worth and this will have 90 minutes worth, so you know which one's right. Before we go to the live stream, just a few bits and pieces to show you. I've done some deals this week with Warren Moulton, who I think is VK3LZ. I'm not sure of the call sign, but I managed to get a genuine 1960s Forest phone made by AWA. These are first generation transistor AM transmitters, so they're quite efficient, but very exotic 1960s germanium circuitry, positive earth and all the rest of it, and using transistors that were no longer available from about 1970 onwards. This represents the transitional technology between valves and silicon transistors that really took over, I think, at the end of the 60s. So, nice little radio. It was used for small ships. That's ships with a P. Anyway, I'm 6'3". And the other bit of gear which I managed to do a deal with from Warren is this. Those of you who may have worked for the ABC will recognise an audio peak limiter. This is an Audimax made by Thomson CSF, probably dates from the late 1970s, but still quite workable. And would you believe, after my original peak limiter popped its lolly about 6 months ago, I spent $250 on a new Behringer limiter, only to have done a deal on that second-hand professional limiter a week ago. So if only I'd been able to hold off for a few months, eh? Anyway, let's now switch over to 147.475 and see if anybody's about for a QSO. This is VK3AML calling CQ on 147.475. By the way, if Mike 7MJ is listening in, thank you very much for allowing me to re-edit the whole of your lecture. I think at least if the audio is not entirely pleasant, at least it's intelligible now. And likewise the diagrams, I hope, are a 1080p definition. Taken off the original PDF, the original PowerPoint should be a lot more intelligible than they were on the original Reist upload. So thank you to Reist also for staging that event in 2017. It was a lecture that was sufficiently solid and backed by technical and scientific physics basis that I felt that it was a noteworthy contribution to the historical record and worthwhile putting on our Saturday night sessions in perpetuity via recording. So that being said, I'll now switch over to 147.475, just 8 minutes after 11 p.m, and let's see who's about. VK3 Alpha Mike Lima standing by on 147.475.
VK3 Alpha Charlie Zulu.
VK3 ECG.
We have VK3 ACZ, g'day Peter, and VK3 ECG, and g'day to you Dave. Do we have any other people for the check-in? VK3 Alpha Mike Lima, standing by.
VK3 BLX.
And hello VK3 BLX, very nice to hear you there too. John, so let's take it from Peter first. Peter, you've been, I think, on a camping expedition with the Sherbrooke Amateur Radio Club, and I hope you'll give us a report on that. I hope that went well, in spite of the weather. I suppose north of the Divide might be a bit better than south of the Divide. And looking forward to seeing you next Monday at the next meeting, held back for a week, of the of the Sherbrooke Radio Club. VK3ACZ and group standing by for you.
VK3AML in the group, VK3ACZ returning. Good evening, Chris. Good evening, Dave. And good evening, John, and anybody else on the side. Well, you saved me having to remind you about the Sherbrooke Radio Club's meeting on Monday night. All good there, Chris. Looking forward to seeing you, and if you require a lift home, that will be done as well. Yes, it was a great radio camp. 3 degrees during the nights. It rained pretty hard Monday night, and there was a lot of water on the ground. The little desert wasn't really a desert. Neither was it little. You didn't walk too far along the bush tracks because they were very sandy, and it was hard work on the leg muscles doing that. But anyway, lots of good contacts made. I'll say more about that shortly. But to get back to tonight's broadcast, I got caught out at the start with the false start that happened there, Chris. But just after the Titanic, I presume the fault was at my end, but it buffered and then dropped out completely. And it did it 2 or 3 more times, so I gave up and just listened to the VHF stream, and it was more than adequate. I would have liked to have seen the slide presentations that were being made. But very good to film. A couple of things only come to mind. I wasn't aware of conspiracy theories about the Titanic, that it was an insurance scam. That would be a very hard one to pull off, really hard. But, the truth never gets in the way of a good story. And a communication monopoly even way back then. Nothing's ever straightforward, is it? Nothing's particularly easy. And, yes, a reminder about Marconi having an invention that he wasn't able to persuade people was interesting about as a bit of a surprise as well. But anyway, as again, I presume it was my problem with the dropouts on my telephone reception at this end and not on your broadcast tonight, so I hope it all went well. It was certainly a very interesting presentation to be made there. VK3AML in the group, VK3ACZ.
VK3ACZ and group VK3 Alpha Mike Lima. Sorry to hear about the 3 degrees C and little desert, but then at the best of times, deserts inland tend to be very cold overnight. I remember Dave, 3AOC, telling me that when he went to the EMU nuclear test site, the atomic test site in northern South Australia during winter, that overnight it could frequently drop below freezing, whereas during the day it was up around 25-30 degrees. So not exactly the most hospitable places, deserts, as you might expect. But I would think that if you saw it in wet conditions, Peter, you'd be seeing lots of wildflowers eventually coming out. And hope to see you Monday night. I gather that's day after tomorrow rather than next week. As for the false start, I don't know quite what happened there. I keyed up to start streaming, and immediately, for some strange reason, my web browser dropped. So I had to stop the streaming and then start the streaming again. And obviously somebody must have been watching, because at one time we had, I think, 17 lookers in simultaneously. So people were finding their way to it. But I've no doubt that our numbers were down on the stream tonight because of the problems such as you are describing. And when I finish the stream tonight, I will get into my YouTube channel and eliminate the false start. I'll just sort of erase that recording. I hope I can. It's never happened before quite this way. Dave, VK3CG, I hope you're doing well tonight. As you may have gathered from the things I held up earlier, it's been a rather nice week. Warren Moulton is moving from Camberwell Junction down to Mount Eliza. Not downsizing, but getting rid of some superfluous equipment. And the peak limiters were superfluous to his need, as was the low-power 160-metre AM rig, which might have some interesting applications for portable operation. It doesn't draw that many amps, and of course it is transistorised, but only just transistorised. I mean, I think that was the ship's radio, the first one made by AWA, to replace the last generation of valve gear. So round to VK3CG. How's your week been, Dave? Anything interesting happening? I have some news on the music scene too to pass on when you finish. VK3CG and group VK3AML.
Yeah, VK3ECG with the Paul. Good evening, everyone. Good evening, Peter. Good evening, John. And good evening to you, Chris, as well. Thank you very much. That was a very, very interesting and instructive video, and great here at lecture like that, and great work at putting those PowerPoints and embedding them in the original recording. I know what that's like. We do that from time to time, and so on, and it's certainly well worth it. And then adding to the process with some original audio recordings, I think that helped a great deal. It sort of takes me back to the beginning of all the COVID stuff, when I was doing a little bit more work at those days, and massively just transferring large amounts of lecture material. So I used to go up to Monash and go to the little audio visual studio there, and they'd have a couple of camera things set up, and you could run your PowerPoint and then have yourself as a little sort of animated icon with a green screen behind it. So you just stood in the corner of your slide, and you could point to things, and you could see it all on the screen. It was rather fun, actually. And just basically recording lectures. I really don't like doing that, actually, I have to say, because every now and then now they say to us, "Oh, we'll just run your recording," and I keep saying, no, even if it's online, I prefer to do it live, because things. It's not that things change so much; it's just that there's always something you can refer to that's happening in the news or something like that, which is interesting. It's been a sort of interesting week. I spent most of my time actually around Camberwell Junction, as it turns out, because my daughter has bought a unit, and so I've been over there doing things again. I think I was doing it the week before as well, building things and putting on sliding doors onto IKEA furniture and things like that, which is never a very easy task. But it was certainly interesting weather as well, and so I can sympathise with Peter about the cold and the wet, although it'd be really interesting to hear how the camp went and so on. I think my musical sort of things start next week, so that'll certainly be interesting. I really like that Morse code. I'm tuning up my Spark. Dit. I shall have to remember that one. Although I suspect if I ever use it, no one will know what it is. I am trying to get my Morse back at the moment. But my reading's a bit slow. I mean, I can probably do around. If I'm really concentrating, I might get to 10 words, but a minute on receive. But I can transmit around 20 and so on, which is probably all I need to be able to do. But I'd like to make some of the portable stuff, low power stuff, and start using CW. I've just got to get my reading up a bit, and have a go at that. So that's my little task, if you like, that I've got to try to finish and so on. Maybe I'm over trying, I don't know, but it's the inter-ear processing that Mike was talking about. That's the issue, and it's a remarkably fine filter, but you still have to train it. Back to you, Chris. VK3AML group, VK3ECG.
Yeah, Dave, VK3CG and group VK3AML. The point, I think, was well made by Mike, that when they went from coherer, which was just a switch basically for receiving, to using headphones and listening directly to the signals off the air, they finally had some, I think, Captain Round of the Marconi company called it communion with the surrounding space. No longer were the signals just switching a medium on and off 2 states by stable, but you were listening to individual signals and their characteristics, which the ears could filter. Just while I'm on the subject of what we were showing earlier, the Forest phone, I've just taken the cover off this thing, and this is an example of AWA manufacturing. Circa 1965, I would say. Rather nicely made, first generation printed circuit boards, and all nicely done with fiberglass, which was unusual then, but these were designed for shipboard installations. You can see that there's 2 crystals in there, one I presume for transmit, the other for receive, and this one's tuned to 1843 kilohertz for reasons that'll be obvious to anybody who's involved with maintaining old analog TV sets. And on the back I've been warned by various people not to pop these transistors because they're very early. 2N310 I think one of them is. Hang on, I'll just have a look. 2N301. 2N301s are the finals, and the modulators are a smaller type of transistors, but all with the sort of TO3 mounting, and they're apparently completely irreplaceable because they're all high-powered germanium, which hasn't been made for over 50 years. So I've got to be very careful with the antenna loading on this, make sure that it's always correct, otherwise I pop them and this whole thing becomes unusable. But it's just a lovely piece of first generation fully transistorized radio transmitting gear, and quite apart from the fact that it's a functional 160 metre transmitter capable of 10 watts AM, and that's a band on which AM has persisted, it's an interesting museum piece of an age, particularly in Australian manufacturing, that's now sadly past. Among the many good things that the Whitlam government did, dropping import tariffs on electronic goods was not a good thing for so many people in our industry, and it resulted in a crash in the local manufacturing industry on the negative side. On the positive side, I suppose we can now afford Chinese-made rigs that are 1/100th the price that these things would have been in their day, but that's the price you pay for cheaper labour, I guess, in all sorts of ways. So now it's over to John, VK3BLX, to take. Hope you've had a good week, John. Nice to hear you there again, and I hope you didn't get too flummoxed by the false start, to which I sincerely apologise. By the way, Peter, I don't think the problem was at my end with the stream, because as far as I could see, the stream didn't have any lost frames once we got it running properly, and it seems to still be running okay. Let's have a look. We've got 15 people looking in. Hello to the 15. Paul VK3HN is there, and he's given some compliments to Mike VK7MJ over that, which I'll certainly pass on. If Mike got flummoxed by the false start, I'll put him right and send him a URL for the whole thing so he can watch it with time delay. So, VK3BLX and group VK3 Alpha Mike Lima standing by.
VK3AML on the group, VK3BLX. Oh, good evening, Chris and Peter and Dave. Good to hear you all there. My apologies for only ever turning up about once a month on this on this test transmission, but at least I've made it tonight. There always seems to be something else happening around here, but when the opportunity presents itself, I do like to come up and say hi. Tonight's test transmission I found really interesting. Certainly, there's lots of bits and pieces of that I've come across in the past, and I do recall reading a fair bit about Marconi at one stage, but there was so much other really fascinating stuff there, all the various techniques used to generate RF and to receive it. Really fascinating stuff. Oh, gee, didn't they know how to go big? I mean, I've been impressed by some sort of big steam engines and things that I've seen, but they're all relatively straightforward compared to something where you're running sort of hundreds of kilowatts and, generating RF with spinning discs and arcs and God knows what else. Gee, fantastic stuff. Now, on your stream drop, I started watching the first one, and you said, oh, hang on, something looks like it's wrong here. And then the stream dropped. And I was wondering whether that's what you would have expected I would have seen, or whether you thought there was something wrong and killed the stream and started up again. I'm not sure. But anyway, the first part of it all seemed fine until you said, oh, it looks like there's something not happening here, and that's when it stopped. So I straight away went and had another hunt, and sure enough, there was your new version of it, and that ran 100% smoothly, no problem at all. Perfect as usual. The one thing, I did start listening to the 2 metre channel right at the very start before I got the YouTube one up, and I got the impression from a very short listen that the audio on 2 metres was quite a lot worse than what it was on the YouTube stream. So I don't know whether anybody else compared the two, but certainly the YouTube stream, I found the audio actually, very intelligible, no problem at all. It was obvious the microphone was on the other side of the room, but that didn't seem to affect the intelligibility much at all. What else was I going to comment on? Oh, interesting, you mentioned Warren Moulton. I don't know how active he is. I only remember the name because at the time he first got his ticket, I think I worked him on 2 metres. Probably would have been where I would have been working on those at that time, and he was a radio announcer at the time, as I recall. That's sort of how I remember his name. Morse training, just got an interesting little tale there. I learned my Morse to move from the Z call to my full call. I don't know, when would it have been? Back in the 70s. I can't remember the exact date. But at the time I was working for, was it Telecom then, or the PMG? I can't remember when we changed over. But I had access to telegraph stuff. I worked in the telegraph lab, and in my spare time I concocted a bit of logic. We just started working with TTL logic and all that sort of stuff, and I concocted a Morse generator out of a paper tape reader, and it's a 50-volt magnet in the thing, so as I recall, had to have a big power supply and all the rest of it in the logic supply. It read the paper tape at variable speed and also variable character spacing, so I could run the characters at probably up to 20 words a minute, but space it out to a few. And I'd sit down and sort of punch up a big long tape on one of the teletypes, and then at my leisure feed it into the tape reader and adjust it and put the headphones on and sit down and work away trying to master Morse. It worked pretty well, actually. In the end, I was receiving at the 10 word a minute, very, very well. I got my ticket and never ever used it. So all that effort for what? Just to change my call sign, basically. Oh, I did get on, of course. I was on HF phone, but sadly never made use of the key. And the last comment was on germanium transistors. Well, I distinctly remember the what was it? What was that one that you mentioned? 301, something 301. That rang a very loud bell. I remember building my very first sort of radios post-crystal set with valves, and then the old OC70 and 71 or OC55, things like that. If you remember those early germanium transistors, building my 1 and 2 transistor set. And then I built a probably 7 transistor, maybe more, Radio and Hobbies AM receiver. And when you held up that AM transceiver there, I recognised pretty much all the components, all the same sort of vintage. And I know I used some of those little IF cans with a little bit of rubber sticking out to keep the slug in place. So that really brought back some memories, that did. All right, I've yabbered on enough. Back to you, Chris, VK3AML on the group, VK3BLX.
Yeah, thanks, John. And I'm aware that there were VK3BLX, VK3AML returning. I'm aware that there were Morse practice machines available, I think the 30s, 40s and 50s, that used paper tape that you could buy as part of a course, and the advantage was that you could run it at variable speed and it would key the oscillator at the same tone frequency regardless of the speed of the tape through the machine. They, I think, were kind of superseded by cassette tapes by the time I got involved with a Morse course. In about 1984, 3 or 4, I went to the Wireless Institute's Victoria Division rooms in Brunswick Street, Fitzroy, I think, and enrolled in a Morse course run by the late Ron Cannon, VK3BRC, and he was one of the great old stagers who'd been involved with ham radio, I think, just in the last few years pre-Second World War. Nice old bloke, very kindly, and he pulled a few tricks on us as we were trying to get our speed up. One of the things is maintaining concentration. Transmitting I found much more easy than receiving, and I wasn't surprised to hear Dave say that he could transmit at a much higher rate than he could receive. I have the same problem. But Ron would throw in practice sentences that using one particular letter. And he'd throw in the sentence with a sort of a joke associated with us to try and throw our concentration. And one particular sentence really threw me. I started laughing, and then the whole table got the giggles, and Ron had to admonish me. And the sentence that he was sending in Morse, practicing the letter G, was "Genial George gesticulates geometrically." Genial George gesticulates geometrically. I got the giggles. I don't know what it was about that sentence. I found it funny. And I started tittering, and then the whole group started laughing, and we had to go back to square one and start again. So I can do Morse, but I don't find it restful or enjoyable. It's the sort of thing that I would use only if no other medium could get through, and frequently Morse is useful in that way. Round to Peter, VK3. Oh, and I should say, I was preparing for doing a licence in 1983-84, but almost immediately I finished the Morse training course. I was posted to Canberra, so that I had to leave all my gear behind in Melbourne. Worked at the National Library, didn't have the opportunity to go for the ham ticket at that stage, and put it off for 25 years. Or 20 years, I think. And by the time I resat the ham licence in 2005 or 6, Morse had been dropped as a requirement. I almost say thank God, because I never found it terribly entertaining or engaging. Some people thrive in it. I didn't. VK3ACZ and group VK3AML.
VK3AML and the group VK3ACZ. Yes, and I'm not too sure why some people are enamoured with CW. I really don't get the great attraction at all. In fact, I even have trouble decoding it on my FTDX10. It has to be right to the exact number of words per minute, or it comes out gobbledygook, and I just fiddle around tuning until I get something of a decode. Well, there you go. Couple of things to convey about the Sherbrooke radio camp that we had this week. Jim was a very happy camper, VK3AMN. We had a strange experience. The two of us were standing about 5 feet apart next to the campfire of an evening, and all of a sudden I felt a flutter of wind caused by wings, and it was a tawny frogmouth who jumped down between us to pick up a moth or whatever it was, and then took off again, climbing at a 45-degree angle, narrowly missing the fire itself, but both of us could have, because we were only standing 5 feet apart and he was in the middle of us, either of us could have grabbed him on the way past. Not that we would have, but it was just one of those funny little sightings. Magpies came in and fed out of our hands, which was kind of cute. Emus were very interested in us and came over to have a look quite often. One funny thing is I was talking to people in Melbourne on 40 metres and they said, oh, hang on, I have to turn the volume up on the radio to hear you. It's hailing so hard. And I looked outside and, of course, there's not a cloud in the sky. We're only 350 odd k's away from Melbourne itself in the little desert national park, just the other side of Dambulla. But when I got there, Jim had put up his G5 RV in the only two really tall trees around it, up about 70 feet. So instead of using my own flower pots or similar, I just used his G5. Had some great contacts on 20 and 40. Unfortunately, the solar figures weren't that great. The solar flux index dipped under 100 and we were down to 0 sunspots again, which I didn't think I'd see again in a hurry. I think it affected 10 and 12 because I didn't hear too much on them. Some good contacts on 18 and 20. Couple of special event stations. I'm always a sucker for them, but this one was Hotel Bravo 90 Juliet Uniform. And that was celebrating the 90th anniversary of the Junkers aeroplane. And of course, as soon as I became aware of that, all I could see was Adolf Hitler climbing on that Junkers that he used to fly around in, with the three engines looking weird with the engine on the front of the fuselage as well. Another interesting contact I had was VK0 Whiskey November down there at Casey Station. Warren is down there at the moment, and if you have the chance to have a talk with him, anybody, grab it, because he's just got an amazing way of describing what life is like down there on Casey. I had really only one question I could ask because he was so good at filling in the gaps about what life is like down there. My question was, do you see the sun at all this time of year? And he informed me that, because they're 66 degrees south, just the very tip of the sun travels across the horizon for a little bit, which took me back a bit because I remember being in the top of Ireland a few years ago, right at the height of summer, and it never got completely dark, and that was only 55 degrees north. Most unimpressed because I wanted to look at the Northern Hemisphere stars, and I was in, the first time I was in regional areas, away from light pollution and all that, but no, the sun provided its own. But anyway, the other thing is there's a Shires contest on this weekend, Chris, and that allowed me to have a little bit of fun this afternoon. I brushed the cobwebs off my FT818 and made some QRP contacts with ZL and VK5 and VK4 and all that, and very gratifying to get what I believe are genuine 5.7s and 5.9s from ZL. I believe they were genuine and not just flattering, because they expressed their surprise that 6 watts was doing such a good job. Anyway, that's enough for this over. We had a great time at the radio camp. Unfortunately or fortunately, you'll probably hear a bit of it from Jim. He did a fair bit of sound recording and video recording while we were down there. Beautiful spot it was too, on the edge of the little Desert National Park. Back to you, Chris, a VK3AML in the group, VK3ACZ.
VK3ACZ and group VK3AML. It's very interesting. I had a friend, a very good friend, who died 2008, Frank, who came from one of the railheads just outside the little desert. I'm just trying to think of the name of the place. The railhead was disbanded sometime in the 1950s, but he went to school. He was born in 1932 and went to school round about the wartime, and he told me a story about the tawny frogmouths in the little desert. Generally they sleep during the day. They're nocturnal. Nightjar family, I think. They're raptors, but they're not owls. They look a bit like owls, but they're from the nightjar family, which is a distinctly different family. Anyway, this this tawny frogmouth was sleeping on a branch at about head height, and Frank was on his way to school. He would have been in grade 6, I suppose. And he told me we broke the twig off the eucalypt tree that the thing was sleeping on, and it kept sleeping, so we carried it through to school. And we stuck it in one corner of the room, and there's this, the teacher's teaching, and there's this tawny frogmouth just sitting there asleep. He said, so at the end of the day, 4 o'clock, I walked forward very carefully, gingerly picked the stick up, the thing blinked a couple of times, went back to sleep, carried it back to where we found it, and he said left it there, and it seemed to be quite content sitting at the foot of the tree on this branch. It must have woken up. He said, many times, he said, since that time, I've often wondered what sort of dreams that bird had. Did it dream that it went to school one day with the human kids or something? But they're remarkably docile when they're on the edge of wild country like that. I don't think they're used to any depredations by humans at all. I think I'd be a little bit worried if emus came around in too large a number. I've had the experience of almost being attacked by an emu at a place called Tower Hill near Warrnambool on one occasion. I was stupid enough. One emu came up to me, and I was eating an apple, so I offered it a section of apple, and it swallowed that, and as soon as it did that, about 4 of its mates came out of the bushes and headed for me, looking distinctly aggressive. The trouble was I had to duck down to get into the VW Beetle that I'd driven there in with a then girlfriend. 1979, it's a long time ago. And when you duck down, they get really aggressive, so I had to duck down, slam the door, and then she put the foot on the accelerator and we got out of there. But, emus, not a good thing. When we come round to you again, Peter, I'd just like to know how you elevated your antenna wires at this camping spot in Little Desert, because I don't think much grows there that's above the height of mallee, which is about head height. So you'd probably need spider beam poles or something to get an antenna up there. And with that being said, we'll hand it round to Dave and your daughter, located in Camberwell Junction. I spent my first 30 years in the Camberwell Junction area, off a street called Pleasant Road that runs between Taronga and Burke, and in those days most of the houses were big single-storey Californian bungalows with big backyards and trees and rose bushes and hedges and lots of area for the kids to play in and trees to climb and dunny-cart lanes to play in. But I go back there now and I barely recognise the area. It's flat land, unit land, very few Californian bungalows left. Every time I go there, there are more demolition sites of houses that used to belong to the families of kids I went to primary and secondary school with. All rather sad, so I don't go back very often. VK3CG and group, VK3AML.
Yeah, VK3AML and group, VK3ECG. Yes, left us pause if anyone else is around, but I didn't hear anything. Yes, I was. It certainly is an interesting place now and changed dramatically. Yes, I know where Pleasant Road is, and my daughter's on. It's one of those big places, old places on Burke Road, but it's sort of part of a unit block next to it, and so on, which is quite a nice area, and it's a lovely place to be. But it's changed dramatically, as you say. I mean. Alexander Park, I think it's quite close by, and so on. Yes, I mean the mansions that are around there now are truly amazing, some of them. But yeah, it's, and being attacked by emus, I don't think I've been attacked by an emu as such, but apart from it, when you try to feed them with some seed or something in your hand, whereupon it's like someone with a pneumatic drill tapping at your hand, but that's emus for you. I think the cassowary is probably up in far north Queensland is probably a far more dangerous creature. They actually do kill people, I think, occasionally. But I did like your Morse code of the genial George, and had a quick go at that. That's not too bad. Good practice for the G's, as you said. Yes. No, I agree. My Morse code sort of experience was really having got my a B call, as it was referred to, a B class license in the UK, and then doing my Morse a little bit later, actually, probably would have been almost 10 years later, and fortunately, I think they took pity on me because they sent me a piece of medical text, as it turned out of a textbook that was on the desk. And I don't know if they actually knew I was medical or not, but it was something to do, I can't remember now, but it was something to do with some sort of lung disease. But of course, the words were fairly straightforward for me in that sense. So, and of course, the UK test was, I think, 12 words. I think the Australian one was 10, wasn't it? And 12 words. So, not there's an awful lot of difference between 10 and 12, except when you're struggling to receive it in the early days. And normally they like people to get to at least 15 before they did the test. But I was literally due to leave very soon, and so I stuck into the test early, and I think they were sort of quite nice to me at the end of the day, and I scraped through that and so on. But really haven't used it much since, just sort of been practicing on air with people from time to time, and that's about it. But I'd like to get it up because I think it would help with some of the sort of portable things. And yes, with what I've done with my portable system has been just to set up just a fiberglass pole in the middle, and then just run a single guy off that, and then run the two dipole wires on each side, then guide down to the ground, in effect. So with some cord, and so that gives you and if you just bend the dipole very, very slightly, it just gives you a slight tripod on the pole. And you can either peg the pole, of course, with the guy and the active antenna wires, or you can just tie it off to bits of shrub and things like that. So I've done both, and it works very well. So you don't need to necessarily have a tree, but then you've got to carry the pole. So it's like you've got to make your choice, I think. Yes, I liked the AWA. It was nice. I remember, I think one of the first radios I ever had was an old Taxi Pi Ranger, which was a valve 2-meter AM crystal controlled transmitter, and it was so really was quite a funny old piece of equipment, and it still ran on 12 volts with some sort of inverter thing inside, which made a bit of noise. But we used to, a friend of mine, and we got a couple of these, and some other people, I think, and we had it all sort of net a couple of times a week and things like that, which was quite fun. You wouldn't want to be using one of those sort of things these days. Yes, the hail and the noise on the tin roof, Peter. Yes, that happened to me once. I was giving. It was quite a few years ago, and I was giving evidence, I think, in a trial in New Zealand. It was in Greymouth, I think, and I gave this long, complicated answer to a critical question, and when I stopped, there was sort of silence at the other end, except some just a general white noise background, whereupon the judge started shouting at me and saying, "I'm terribly sorry, Doctor, we can't hear a word you're saying. We've got a tin roof for this courthouse, so we've just had a massive hailstorm. Hold on a minute." it was, and of course you could never give an answer again like that. So I had to start all over again. But yes, those sort of things can be quite fun. Yes, the other thing I remember, talk about communion with the surrounding space. I like that reference, And of course, sometimes, and I think it was Heil, one of their headphones, they had a little phase switch, so you could actually just phase out the left and right ears and create a phase difference, which gave you a sort of a spectrum in your head, so that signals at different pitches slightly would appear in this sort of stereo spectrum at a slightly different place, and actually designed to sort of help you pick out a signal. I suspect it would be more valid for CW than it would for sideband or something, but an interesting approach, and it's interesting when you start getting these different sort of brain filter interpretations of what's going on, and it's remarkable how good our brains are at that sort of distinguishing characteristics. And even the context can be important. You catch halfway through something and you're not concentrating, and it seems to be completely gobbledygook, and you listen to it again, focused and concentrating, and it's actually quite clear. And sometimes you get that in, just watching bits of TV where you just can't hear what someone says in an advertisement or something. And as soon as somebody points out to you what it is, automatically your brain fills in all those gaps. It's a bit like having a very muffled signal and just putting white noise on the top of it actually improves the intelligibility of a voice, which I've always thought is absolutely fascinating. In relation to the daylight and sunlight, and as I said, I once went to and spent some time with a family in Tromsø. This is the northernmost university in the world, I think, and that was 24-hour daylight, and it was, kids were quite young at the time, and we literally had to get the cushions off the sort of sofa and the chairs and put them up over the windows, because it was too light, even with all the curtains closed, to sleep at night. It was really quite impressive how light it actually was, 24 hours a day. So fascinating, yeah. Anyway, back to you. VK3AML on the group. VK3ECG.
Thanks for that, Dave. Tromsø. I think that's as far north as you can go in Norway without going offshore to Svalbard, Spitsbergen, where I think there's a small town, even further north and even more barren. Tromsø. Interesting. So I wonder if you ever saw the Northern Lights from there. That would be the best place to see it, I should imagine. Bob Heil with the headphones, yes. There's a way of receiving signals off web-based STRs called the IQ demodulation process. You can feed, effectively, if you phase up the two stereo outputs of your sound card the right way using that, you can listen to AM with one sideband in one ear of your headphones and one sideband in the other ear. And when you're dealing with very low AM signals, it's a very interesting effect, because you can actually you get a, how could you describe it, a directional effect as the selective fade goes through the band pass and affects one sideband more than the other. It's fascinating, but it's more information from which your brain can filter noise from signal to get the audio off the AM transmission. And I noticed the number of as soon as I started going on about that, the number of viewers on the live stream dropped by 2, so I better get it back onto an even keel. Just replying to some people on the live stream, Paul VK3HN pointed out with the Forest phone that I showed with the early germanium transistors, the metal cans over inductors may have been Neo-SID 722/1 bases, formers and cans. They had metal cans single and double. The slugs were locked with fine rubber threads and they worked very well, completely replaced by toroids from the mid-1980s. very likely so. And Graham Thomas, VK3DLW, apologises that he hasn't been able to catch up with the test transmission this week. His family's visiting from South Australia playing basketball, and they had a late match, so he sent his best 73s to everybody. Hopefully we'll hear from him next week. That's Graham, VK3DLW. Pi Ranger, I think, was one of the radios that my predecessor with my call, Tony Sanderson, had. I think it may have been early FM, either that or late AM. There was a time, sometime in the 60s, when most of those mobile radios went over from AM operation to FM, and generally they used valves like the QQVO. I think the base stations used a 640 and the mobiles used a 320 valve from memory, with often with a transistorized inverter to get the HT. The earlier ones would have had a vibrator power supply, and I could make a filthy joke about that, but I will refrain, and you can fill in the gaps yourself. The Shires contest, Peter, I don't know quite what that is. I presume it's making contact over a maximum number of shires, presumably of either Australia or New Zealand. I note you took out your FT818. Greymouth, Dave, a very interesting place. I did a tour of the Transalpine Railway from Christchurch to Greymouth and back with Mike, actually, VK7MJ, who you saw earlier tonight on that lecture. And Greymouth was an interesting old coal mining town and port, one of the few ports on the west coast of the South Island of New Zealand. And I don't think I'd be telling stories out of school to say that there was a cafe in Greymouth called the Vape, V-A-P-E Cafe, which had advertised up on the door, Internet Cafe. Mike and I went in because we wanted to send emails to our respective spouses or family, and there was one computer terminal, probably running Windows 98, rarely used, and we couldn't get it to work at all. And people were coming in and out of the Vape Cafe buying little brown paper bags of something over the counter. So we asked for our money back on the Internet Cafe and gave up on it. But I'd say it may have been a bit of a front. So that left a lasting impression of what Greymouth was. Apart from that, it had some very interesting shops, and the sort of people that lived in Greymouth had this, how could I describe it, a kind of an insular mentality that the only local parallel I can think of is the mentality that I've struck in Queenstown in Tasmania, similarly a mining town that has its own character and identity separate from the rest of Tasmania, because up to the 1940s they were quite separate from the rest of Tasmania in terms of transport. Very few roads in and out. I think the first road in from Hobart was only pushed through in 1932. Before that, there was more traffic with Melbourne via ships than there was with the rest of Tasmania to Queenstown and Strahan. Interesting places. Going down the list here, tawny frogmouth, magpies, always interesting animals, Peter. Very intelligent birds. Most birds of the crow family are. I'll get back to that later on. Over to you, John, VK3BLX, and note your paper tape Morse practice system that you made one yourself. I think that's very clever. VK3BLX and group, VK3AML.
VK3AML and the group, VK3BLX. Yeah, well, I was very keen and fired up in those days. I just sort of was learning a lot about designing stuff with digital logic, and it was probably as much the challenge of designing it and building it as much as anything, but it certainly did work. I always figured that it was best to learn Morse with the characters at 10 words a minute, which is what I was going to be examined on, and then just sort of space the characters out until I became a little more proficient, and that sort of closed the gaps up progressively until I could handle it all at normal speed, and it worked quite well for that. But I used to use headphones with it because the tape reader is going clunk, 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 clunkety, clunk, 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 clunk all the time in the background as I'm listening to the tone in the headphones. Dave, you mentioned, when talking about birds, you mentioned cassowaries. Brings back a memory of a time we were up well north of Queensland, and we visited a local wildlife sanctuary there, or there was a bit of a zoo. They had cassowaries in big cages, like runs there. And one of them had taken a dislike to one of the zookeepers. The thing didn't really pay much attention to us, the tourists, hanging around looking at it. But as soon as it spotted this particular zookeeper, it just went crazy and it ran up and down trying to get at him. If he'd been able to get to him, I think he would have torn into pieces. I honestly don't know what had made it like that, but by crikey, it was an aggressive thing. As you say, if you ran into one of those on a dark night, you would be in serious bother. Chris, just a brief note on those old radios here. I think my first 2-metre FM radio was one of those ones that you were mentioning. I remember it was all fully transistorised apart from the final. It might have had a valve driver, but certainly the final was a QQEO 320. And I think it had a transistor inverter in the thing for the high voltage. I think I had about 2 channels fitted to the thing. One side converted it to run on 2 metres, probably channel A and channel B, and that was it. I don't know whether there were any repeater channels or whether there were even any repeaters at that stage. It was a bit of a dog and an old thing, but it worked. I haven't got much more to add, I'm afraid. I may disappear. If you put it over to me next time and I'm gone, you can conclude that I've taken off. So just in case that happens, good night to everyone. Nice to catch up again, and till I have another free Saturday night, we'll see you. VK3AML and the group VK3BLX.
Well, thanks for popping up, John. Always a pleasure, and nice to hear from you. The variety of ex-mobile service VHF radios that I know a lot of friends of mine started on. Tony, I think, had a Vinton car phone, which was all valve, and I think it had 10 watts out. It was very rare you'd see a VHF radio at affordable prices in those days that was more than 10 watts. I'm talking the early 70s. And they drifted like an open boat. Usually they weren't frequency agile, and the front end noise level by modern standards was extremely poor. So you'd rarely hear, for example, if a radio was on and you were listening for DX through a decent antenna, you'd rarely hear Tasmania in those days. These days, whenever there's a temperature inversion across Bass Strait, immediately the first thing I can hear is the Mount Reid repeater on the northwest coast of, or near the northwest of Tasmania, one of the closer of their repeaters. So the noise levels on these new Yaesu rigs made in the last 10 years are really phenomenal. So much better than anything with valves. What else was I going to say there? Getting back to Peter, the VK0WN Casey Base. What did he tell you about Casey Base? I'm just curious. At this time of the year, he wouldn't be seeing much sun at all. And it's funny to think that when you're near the pole, you'd be seeing the sun rather than going from east to west across the sky. You'd be seeing it doing circles around the horizon, the full 360 degrees almost. Having never experienced that, having never been south of the Antarctic Circle or north of the Arctic Circle, it's a different lifestyle. It would take a bit of getting used to. I have friends who live north of Helsinki in Finland, internet friends, a family who live on a barley farm outside Kotka. And in winter, the lady of the house once told me that it's difficult to fend off depression because with the cold weather and the absolute darkness day after day in the middle of winter, it can lead to a certain sort of stir craziness, I suppose you'd call it, housebound stir craziness, depression. Whereas in summer they can have barbecues at 11 o'clock at night in full sunlight. Different life, very different life. Of course, there are inhabited land masses in the northern hemisphere that go far closer to the pole than any inhabited land mass in the southern hemisphere, where it's mostly sea for the last 1,000 miles around Antarctica. So back to Peter. Tell us more about this VK0WN and a bit more about your experiences in Little Desert. Was it a comfortable place to be camped? Did you have reasonable comfort yourself? And perhaps you'd like to expound VK3ACZ and group, VK3AML.
Yeah, VK3AML, VK3ACZ returning. Well, the most important part out at Little Desert when it's 3 degrees overnight is being able to sleep. And Sandra and I were very fortunate that we've got good quality sleeping bags and we're toasty warm because, it's awful if you can't sleep. And you definitely can't when it's cold. But you asked about how high the antennas got. Well, the camping ground itself had a couple of nice-sized trees that Jim utilised quite well with his flicky, as he calls it, which is a nice rubbery slingshot thing on a long pole, and there's no tree yet that I think he wouldn't be able to get an antenna to the top of. We've been limited in a couple of camps that the dipoles haven't got up very high, but this one wasn't too bad. And I said in the previous over, signals are good on 20 and 18. Of course, you realise I meant I got my meters and my megacycles mixed up there. It was 20 and 17. I mixed up my 17 and 18, and not to worry. Still on the subject of Little Desert, Sandra went off into Dimboola and took a photo of a turkey walking along the street, and there's a fella there who has a pet turkey, and if I hadn't seen the photo I might not have believed it, but he does. He walks along the main street of Dimboola with the turkey. Didn't get to see Dimboola this time because the highway bypasses it, of course, but I'm assured that it's still there. And you mentioned before getting the VK7 repeaters, I find Valentine's Peak is the one, if we have a good inversion with some high pressure zone and some tropo, it's usually Valentine's Peak and 6 metres as well as 2. Although a couple of times there I've got into 70 centimetre repeaters on VK7 and nothing else. So yeah, definitely don't understand quite how tropo works. You mentioned the Vinton car phone. Oh yes, now there's a name. The old Vinton radios, yes, converting them over so that we could listen to the Constabulary when they were on 168 megs. Yeah, they were the days. Shire's contest, Chris, I do like a contest, I really do. Not to compete or take part in them, heavens no, I don't have enough energy for that, but I like giving out numbers and I like picking and choosing, and the identifying feature is you give the 2-letter call for your shire, which in my case, being Knox, it's Kilo X-Ray 3, and every shire throughout Australia's got a listing. The ZLs who were joining in and actually calling CQ Shires contest, they were giving the 32 as their region number rather than a shire, but they were actually taking part. So don't know the full story about that. I was just grateful, and at least with Australian contests, whether it's Remembrance Day, John Moyle, whatever, at least you can have a little talk with the person at the other end. Oh my goodness, the CQ worldwide and those sorts of things, I think I've said this before, but I think first prize is either a car or a block of land, because the way they carry on, you're saying 7-3 and they're already giving the call out to the next station. It's very cutthroat and very A 3-word exchange would be overdoing it, I think. But anyway, and Dave, you mentioned daylight all night. Oh man, would I find that eerie. I really would. I was being up the 55 degrees north. It was frustrating enough, not being completely dark at night, but I was quite amused being out in the paddocks and looking at my watch at 11 o'clock at night and not needing to press the light button to see it. Just a reminder that things are different in other parts of the world, and I suppose I'd like to experience it. I'm not sure how I'd go with nighttime, 24 hours a day. Warren down there on Casey, as I said, he had a brilliant way of describing everything. But the sun it barely appeared above the horizon at all this time of year. Just a little slither of it, he said. It's 4.5 hours from Hobart to get down there in the plane, and he said it was another hour and a half in these tractors to get from their landing strip, whatever it is, to the actual base. He is on 20 metres fairly regularly, he said. He's got a 20 and 40 capability, but he said there's too much noise there. And I remember Zero Papa Delta, Paul, was on Casey for a while there, and I had quite a few chats with him. And he said the ionosonde and a few other things there caused a bit of trouble. He has trouble keeping an antenna up because one storm, which happens quite regularly, wipes it out. And I don't know whether the antenna's buried in snow or whether it just gets blown away, but the conditions certainly sounded harsh, and he painted a very good picture of it. Having said that, love to go down there, love to experience it for myself. Macquarie Island, well, perhaps even better because you'd still see some greenery that time of year. But I was so pleased to have had the QSO with him, Warren, down there. I'm looking forward to more. Enough of this over. VK3AML in the group, VK3ACZ.
VK3ACZ and group VK3AML. Yeah, well, the closest I've ever got to the poles is Stewart Island, south of Invercargill, off the southern tip of the South Island of New Zealand. Again, I went there with Dave 3ASC and Mike VK7MJ, and Mike's one of my closest on-air friends. We frequently head out to exotic places on exploratory trips, although that's been hampered a little in recent years by Mike's ability to walk long distances. But we got to Stewart Island in 2019, and we were told that for the duration of our trip there it was a heat wave. It's 47 degrees south there. It's about, I think, 3 or 4 degrees further south than Hobart. And I just looked at the webcam from Stewart Island today, and it was heavily snowing on the beach down to sea level. So that's far enough south. If you go to the Auckland Islands, a little bit north of Macquarie Island, that's almost 50 degrees south, and you can imagine what that must be like. Stronger winds, more cold, more rain, more snow. It would get to the point of being dangerous. And as a younger man, when they started running New Zealand airline flights over Antarctica, I fantasised one day I'd be able to afford to go down there. Well, now I can afford to go down there, but after what happened with Air New Zealand and Mount Erebus, I've been somewhat reluctant to take a flight. Although people who've done it tell me that it's an experience that would be difficult to beat, except if you took a liner down to those parts of the world and had a look for yourself. Just looking down the list of what I noted there. They had a special station for Junkers Aviation centenary. Good heavens. I think they were among the first all-metal aircraft. The cassowary? I've seen them in zoos, that's about all, and I've heard reports that they are incredibly aggressive, but I've never been further into northern Queensland than Townsville, and I'm told that the cassowaries are further north in places like Cairns and Cape York, so there are a number of reasons I don't go up that far. The other one's crocodiles. Sorrento for next year's holiday, perhaps. Yeah. Now, Dave, with regard to the CW, yeah, look, one of these days I must get it more into CW practice to be able to at least copy it again. It's been so long, I'm right out of practice with it. I'd probably pick it up fairly easily if I wanted to again. Just to note, as you probably know, I was involved with Sound and Film Archives, either as a client or as a donor or as an employee for the better part of 50 years of my working life. And one of the things I periodically came across were Morse practice gramophone records, and at one stage I was offered a complete set. I kick myself that I didn't pick them up at the time. This is in the mid-70s when I was in my early 20s, didn't have much money to spend. But it was a Marconi company set of records made by HMV, the gramophone company, for the First World War. Some of the discs were of Morse practice on sounders. So you didn't hear beep, 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 you heard click, clack, click, clack, click, clack on the record. Other records in the set were of practice for recognising spark transmissions among jamming, which were interesting to listen to, but at the time, these being 20 words per minute, unless I slowed the record player right down, there was not a hope I had of copying them. And of course it was a very harsh sort of a note produced by the buzzer that was actuating the spark coil in the spark transmitters concerned. But such things do exist, and I notice now on various websites there are uploads of samples from those various Morse practice records, the earliest of which I think were on cylinder back about 1910. Never saw those, but 1916, the First World War set, was the oldest that I've seen. From memory, single-sided HMV discs, 12 inches diameter, and shellac pressings. Okay, round to you, Dave, VK3ECG. I seem to be going off on tangents as people who are increasingly elderly seem to be doing it. Perhaps a function of my decrepitude. VK3ECG in group, VK3AML.
Yeah, VK3AML and group, VK3ECG. Yes, fine. I know the feeling. Yes, I must admit your vape cafe sounds like an interesting place, and I understand that Queenstown, Tasmania Greymouth issue. Not that I don't think I've ever been to Greymouth. I've certainly been to Queenstown, Tasmania, but the stories I heard from my sort of, criminal law type contacts in the system was that Greymouth had an interesting criminal background going on in the place. Perhaps no more to be said about that. But it certainly, I've never been stopped by a judge before because of the noise of hailstones on a metal roof. So that certainly was a first. Although I've had a few interesting, slightly strange situations in doing the early sort of video conferencing in the 90s and things like that, which was very unusual, of course, in those days, but for long distance things. And I once had to do a video call through from Christchurch, and this would have been in the 90s, I think, and there the only one that was available that could be used was a backpackers hostel. And I arrived at the hostel, which sounds like going to your vape cafe, and you walked in and there was sort of nothing that sort of mentioned anything about having a video conference equipment. And I eventually found the reception person, and they said, "Oh, it's in the attic." So they led me sort of upstairs, and then I went up into the roof space, walking between the joists, and there in the far corner was a a table with a screen and a camera and a chair, and I was literally in the roof space. Fortunately, I took my own Gideon Bible from the hotel room and managed to be able to take the oath. So it all worked okay. But I had no faith in the process whatsoever when I first arrived. Yes, interesting. The sort of you just mentioned about the tropospheric ducting and so on. I remember certainly on 2 metre sideband in the UK, very occasionally you get some weird weather thing where it would be very foggy and you get these weird temperature inversions, and working from the centre of England, you know, with no more than 10 watts to a halo antenna stuck out of a dormitory window, working into northern France. Which, you know, is again just that amazing ducting and tunnelling that can occur with those really interesting temperature inversions and so on. But yeah, I don't know. I've got an awful lot of other things. Oh, you did mention, Chris, something about some sort of music news you were saying. So I wonder what that was. And yes, I suppose the music things are sort of starting up again now. Now that with the COVID being over, and for me anyway, so that will be certainly nice. Yes, I've got a few odd recordings, but none of the sort of really old recordings of Morse practice stuff, and that's an absolutely fascinating. Yeah, it's always amazed me how people could recognise sounders. I can see, because the sounds would have been different at the beginning and the ending of the elements of the character, but still an extraordinary to think about. When you play on the video when the Titanic message was being sent, I could follow that, and although it certainly was not as easy to do as it would have been with an audio tone. But was certainly clearly recognisable and able to be followed. Yeah, hopefully I'll get my Morse reception up a bit. As I said, I don't really have too much problem transmitting with either manual or with a paddle. I always actually sort of learned more with single paddle rather than squeeze keying. So iambic keying is something I sort of can do, but it's not as easy for me to do as single paddle, and actually some of the really fast people always swore by single paddles, if not the bugs, but I've tried a bug and that was just impossible. Again, I think it needs a lot more practice before you can do that. It's the same with sideswiping and keying. I find that really, really difficult to do. Although, as I said, I have tried. I think it's much more the music type thing. You really have to sort of think rhythms and think sounds when you're doing just the sideswiper, because it's a very odd where you're making the dots on and the dashes on both sides just by timing it as a manual key with two contacts, and that just does my mind occasionally. But it can be done, and the side paddle key I've got now can be switched into that mode, and but it's very bizarre to have a go at it. Anyway, back to you, VK3AML and Group VK3ECG.
VK3ECG and Group VK3AML. Yeah, I've never used a paddle. In actual fact, when Warren was downsizing from Camberwell just last week, he offered me for sale an iambic keyer and a couple of paddle keyers, but I couldn't see myself ever using them. I do have a standard Morse key, just, grab the knob and twiddle up and down. Silver-plated contacts, which you're supposed to keep clean and all the rest of it. But whenever I would do, the very rare occasions that I'd do Morse, I'd probably use that rather than the paddle key. And I can imagine if you push to one side and get a dash and you push the other side and get a dot with those paddle keys, the trouble is that with the weight, the pendulum on the end of it, you would have to synchronise exactly with the timing of the pendulum, and I'm not that good. My fist is not that good. Now, the music thing, I had a phone call with 3SL, Steve Langley, tonight over this. My family has a very long-term association with Castlemaine, the town of Castlemaine, where my great-great-grandfather went there in 1854, like many Cornishmen did. Tried his hand at gold mining, thought there's knobs on this, I'd be better off selling equipment to the miners rather than digging for gold. So he set up one of the first forges and then foundries in Castlemaine, and ended up making really big cast equipment and some of the first pneumatic drills that were ever introduced to the goldfields. My great-great-grandfather, George Vivian, did about 1857-8, very early on, as such things went. But for that reason, I've been involved with the Historical Society of Castlemaine quite a bit, and I keep a track of what's new on Trove relating to Castlemaine, and usually it's very early photographs. They're all very interesting to me, because quite often I can see my great-grandfather's foundry in the background of overviews of the town. But on this occasion, what turned up relating to Castlemaine was music. Castlemaine had a celebration of the pioneers of Castlemaine in 1922, almost exactly 100 years ago to the month. And for that, they got the chief music arranger for Allen's Music in the city here to write them a commemorative song, Home to Castlemaine. A chap named Maury Guttridge wrote it, and he had a good reputation later on as an arranger of jazz orchestrations for dance orchestras around Melbourne, some of which were recorded in the late 20s. Anyway, the very rare copy of this Castlemaine song turned up on Trove from the National Library, recently scanned. And I conveyed it to the Historical Society, and nobody in the Historical Society can read music. But they were fascinated to hear what the tune would sound like. So who do I know who can read music and play a piano? Kate and Stephen Langley. So I rang them up tonight, and I said, if you want a bad baritone to go with your probably equally bad tenor, I'm prepared to come round once you've deciphered the music and sing along, so that we can get them a recording, God help them, at the Castlemaine Historical Society. I'm okay narrating videos, but you don't want to hear my singing voice. But that's the music side of things. It occasionally rears its ugly head, my musical illiteracy in terms of being able to read the stuff. But Steve Langley will fill that in. Bob Heil, just with relation to the headphones that he makes, Heil is a very, very interesting chap with a deep knowledge of audio, and not just relating to music, but also to psychoacoustics with regard to communication, which is where he makes a lot of his money, manufacturing specialised headphones, specialised microphones. And his YouTube clips are pure gold. So whenever you see a Bob Heil clip on YouTube, I suggest, if you're interested in audio, good quality audio for communication, jump on it, have a look at it. Heil usually has something very interesting to say. I'll stand by just in case John BLX is still with us. If not, we'll move on to Peter. VK3BLX, are you there? VK3AML. Silence, so we go round to Peter, VK3ACZ, who I hope to see Monday evening. VK3ACZ, VK3AML group.
Yeah, VK3AML in the group, VK3ACZ returning. Yes, looking forward to Monday already. Should be interesting to see what's planned for us at the club meeting. The the one time I'm disappointed that I didn't go through the effort of learning CW is with, funny enough, Troppo, as we've been talking about, and the repeaters. There have been a couple of occasions I'm not quite sure which repeater I've actually triggered, and it would be nice to know. Sometimes I listen for the last letter and it gives me a rough idea if I can pull that one out, but I'm definitely limited. I certainly admit that as far as all that's go, but oh boy, I love the sporadic E in summertime. It's probably the only good thing about summer. But anyway, I'll make this a very short over and hand it back. VK3AML on the group VK3ACZ.
No worries. I think we're getting to the end of the night anyway. It's 12:29 a.m. About time we started winding up, so I'll hand it round to Dave and then possibly tie the ribbons. VK3CG, nice to have you with us, Dave, as always. Thank you so much, and I'm glad you managed to negotiate the false start and get into the proper playback, but I'm sure most people will watch it from playback later in the week. We only had we had a peak of 19 at one stage watching on the YouTube live stream. VK3CG, VK3AML.
Yeah, VK3AML and group VK3ECG. Yes, absolutely. Yes, I picked up pretty quickly as John was saying. You said what's happening here or something, and immediately the line it broke. But when again, I quite easily found the reversion, and it was fine from then onwards. So I think, Peter, anything you had after that was probably local at your end. I've only got a sort of Wi-Fi link here to the shack computer, so I do get occasional dropouts, but it seems to go reasonably well, I thought. And fascinating stuff. Yes, thanks for that. The historical music stuff. Well, if Steve needs another voice, I'm happy to go there. And Kate's the excellent pianist and flautist, so we can do some multi-tracking. You never know. It actually happened. I organised something a little while ago for a friend of his had written a book on a very famous vexatious litigant in Melbourne's sort of history. I think around would have been around the 1920s or something like that, and but this person had written some music, and this friend had written a book about this woman, and the music appeared in it, and he was saying, "It'd be great if someone could actually play the music." And I found one, a very, very accomplished musician actually, who was on his way off to Germany to work as a companies for opera companies and stuff like that, and I got him to get the music, which I don't think probably had been played for 100 years or whatever, and he it was a jolly sort of marching tune, and he went to the book launch, I think, and played the piece of music on the piano. So there's a bit of a history of those sort of things. But it sounds like this Guthridge piece would have been quite fun. There's a certain sort of style of that music at that era, and I think it would certainly been great fun. So happy to assist with the vocal line if required. Anyway, that sounds great fun. And and as I said, if you ever want to have a go, Peter, we could try some very, very slow Morse and a bit of practice if you really want to have a go at it sometime. As I said, I am most certainly not an expert, but there's a certain sort of whimsical attractiveness to the whole process. Yes, the side paddles. When I was thinking with the sideswiper key, which of course is a straight manual key. There's no auto keying on the sideswiper, and there's no automatic keying at all, Chris. The sideswiper just means you alternate characters and by each side of the key. So if you're sending an R, for example, then you move it left for the dot, right for the dash, and then left for the dot again. but you have to make the timing of the dot and the dash manually as if it was a manual keyer. So if, for example, you were doing H, you'd be just going backwards and forwards, left, right, left, right, left, right, making a dot each time. It's a very, very weird mental feeling when you're using a side swiper compared to any other key. Yeah, I mean, keys are becoming quite collectible. I mean, I've got a small collection of bits and pieces I picked up from swap meets and things like that over the years, and none of them are particularly valuable or good. But there's a certain sort of, some of the old ex-army stuff, and you have to sort of clean them and get them working again and things like that. And I've got a couple of bathtub ones that came out of the Lancasters and bombers and things like that. And you've got to be very careful with the silver contacts, because you mustn't put really any cleaning or any abrasive on them. The best way of cleaning them is actually to use a piece of paper and just run that between the contacts, but don't actually use any sort of cleaning or any sort of abrasive on key contacts at all. Well, there we are. Anyway, yes, look, I'll make this my final as well, and put it back to you, Chris, and have a great week, and enjoy the club meeting and so on, and so to you and Peter. We'll catch up again soon. It's VK3 ECG, often here with VK3 AML and VK3 ACZ. Evening all.
Yeah, all the best, Dave. VK3 ECG and Group VK3 AML. Yeah, just to wind up, it's been an odd week. I've spent, this probably lead into something that I'll take up next week. I've joined a group on Facebook that deals with crystal sets. Crystal sets are easy to achieve in a mediocre way, but can be incredibly complex to achieve with any sort of quality band pass and efficient filtering and matching ultimately of the impedance of the antenna to the impedance of the headphones that you use. So I've been going into, with that group, the design of coils for best Q, and have come to the conclusion that large air cord coils can actually beat any ferrite cord coil, because the ferrite always will have some magnetic loss and some resistive loss as a core material, whereas air doesn't. There's things like increasing the amount of capacitance and reducing the size of the coil to increase the Q factor of the tuned circuit as a whole. It becomes very, very complicated. So I've been going into the circuitry of passive bandpass filters and M-derived filters and all the rest of it. And the group seems to be referring to me for information on how to optimize coil design. So I'm getting into early copies of Wireless World from the early 30s, when TRF receivers made all of this sort of inductor design necessary. Was soon thereafter superseded by the rise of the superhet. And with that, I'll call it quits for the night, and I will erase the false start and direct people thenceforth to the full upload of VK7MJ Mike's lecture from Maxwell to Marconi. So, thanking everybody for their participation. This is VK3AML taking a final listen before closing. Does anybody else want to make any comments? Preferably printable.
Yeah, just a quick one from me, Chris.
Yes, Peter. There was somebody below you too, Peter.
3JS.
Ah, VK3JS. Good day. I'll hand it to Peter first.
Yeah, VK3AML on the group VK3ACZ. Yeah, was caught on the hop last over. Dave, if you're still listening, I wanted to relate a little funny story just briefly. Had a gastroscopy 2 weeks ago now, and funny thing was, the previous one to that I had when I was in my 20s, and things were a bit different. They sprayed a horrible local anaesthetic on the back of your throat. It was very unpleasant, and you were awake through the whole sticking the tube down there and all that. This time, knocked out very nicely for, I don't know, a short period of time, but I opened my eyes, I was there, and they said, you'll just be nodding off shortly, and then next thing I opened my eyes, and I was in a different room, and there was a lady saying, welcome back, oh good, and I closed my eyes again, and I started to dream, and I dreamt that I'd worked a station in Denmark. This is how bad it gets, coming out of an anaesthetic. Denmark's the only country in Scandinavia, Northern Europe, whatever you want to call it, that I haven't worked yet, and I listen on 20 afternoons for the long path quite enthusiastically, hoping to tick off this item on my bucket list. But anyway, I did it in my dream state, and I thought that was so amusing. Is that called obsession or what? But anyway, enough of all that stuff. I look forward to next week already. Chris, thanks again for the broadcast. For the test transmission as always, or what was broadcast on the test transmission. That's what I meant to say. But anyway, cheers and 7-3. Hope to catch you Monday night, and good night everybody. Good night Dave, Chris, VK3ACZ, VK3AML.
Thanks, Peter. I had a good laugh about the gastroscopy thing. If somebody was shoving that down my throat, I think thinking of Denmark and contact on HF, it's the last thing I'd do. VK3JS, any comments there? Nice to hear you there too. VK3AML.
It's VK3VJS, Chris. I haven't had anything shoved down my throat, but I have had, what do they call them? The things down the eye of the old fella. Once with a camera and once to relieve the pressure. And it was quite an experience.
I bet it was.
Especially when they removed it as well.
Oh.
I thought all my birthdays had come at once. Enjoyed the experimental transmissions tonight, Chris. Very interesting on what Mike had to say. And now, my friends the McLeods are down at South Arm. They can have it on their own. When you've got snow on the ground down there, it's not the place to be as far as I'm concerned. And the sunshine, of course, would be even less. I always say that snow and ice are for Eskimos, and they can have it. They sent me a cutting out of the Mockery, and it's about our old friend Nevin Hurst.
Oh.
He's still around, and it appears that at great expense he has bought, I think at auction, a genuine thylacine skull, complete. And he's had a master, what do they call those blokes? Taxidermist, build it up as to what it looked like back in its day. And there's a photo of it and everything. My God, they had some sharp teeth, Chris. Wouldn't want one of those to latch onto you. So that's what our old friend Nevin is up to at the moment. I suppose he's going to stick it in his gallery and scare the hell out of everybody. And as you know, there's a complete skeleton in the Hobart Museum. Now, as you know, I'm a great fan of Errol Flynn, and his father, Theodore, was a Professor Emeritus of Marine Biology. But reading his Professor Flynn's book about his life, he had something to do with the thylacine or the Tasmanian tiger at the old Bamora Zoo, which remains still there on the lower slopes of Queen's Domain. I've yet to find out how he was exactly involved with the thylacine scene. At any rate, thanks, Chris. It was an interesting night. I ran into Anthony today at the HRSA Market Day up at Police Road. I was just backing out of the driveway when he rang me, heading down to the fan park, so I went in the other direction, and I brought home quite a few goodies at the right price. So I'm thanking Anthony for that. And poor old John the Egg, he hasn't got any wheels at the moment. He keeps stripping bolts in his rear axle, unfortunately. So I'm going to make some inquiries through a friend on another frequency who works in the wrecking business if he can get him a not a floating axle, but the other ones. I forget what they call them now. So we'll see what happens. But it was a good day, held by all, Chris, and thank you once again. And I believe the good woman is up and about, taking it easy, so that's good. And good evening to all Peter and Dave, if they can hear this week's signal from Springvale. VK3AML and the group VK3VJS.
Yeah, sorry I didn't recognise you straight away, Jeff. And the McLeods, I remember from your videos of going to, I think, Hogan Island from safety, what do they call it, that anchorage on the east side of Wilson's Promontory, not Preservation Cove, I've forgotten the name of it now, but you know what I'm talking about. The thylacine skull would be interesting. There can't be too many of those about. I remember many years ago there was a mummified thylacine found in a cave, and of which there are many, apparently, in the Nullarbor Plain, which is a limestone area. So there are lots of caves. And this thing must have fallen into the cave. Anyway, there was some theorising going on at the time because this thing was so well preserved, the fur was still on it, that it must have died there no more than 5 or 10 years earlier. Then they radiocarbon dated it, and it had been sitting there for 20,000 years. So, you know, these thylacines apparently were originally right across Australasia, but they were gradually reduced in range until finally the remoter parts of Tasmania were the only places where they could be found, and finally the last one died in captivity in, I think, 1936. And I think that the sort of poisons laid out by farmers in the years since, 1080 poisons and such, would have taken account of the few remaining, if any did. I very much doubt whether any are around now. Professor T. Thompson Flynn, I occasionally used to see articles, archival articles, when I was working in Tasmania, particularly at the Tas Uni Library, by Professor T. Thompson Flynn, Errol Flynn's father, mostly to do with conservation. He was a very early conservationist and an interesting man. His wife was an interesting woman, very good looker apparently, from what I heard. There was one person, now no longer alive, mother of a close friend of mine, now living in Huonville. They were living in Redchapel Avenue in Sandy Bay, quite well heeled. And there is a Mount Pat at Port Davey that's named after her, Pat Benison. She was married to the chief accountant of EZ Industries, so that he was making a good wage. Nice guy too. And Pat could remember her parents being friendly with the then curator of the Tasmanian Museum, who in turn was friendly with T. Thompson Flynn in the 20s when she was a small child, and she could remember Errol just as a naughty teenager. Nothing more. Not for that time anymore. Anyway, that's about it. I'll hand it back for a final, Jeff, and then I will head off unless anybody else calls in. But very nice to hear you there. I occasionally give calls on 475 through the week, but it's very rare that anybody comes back. And usually when they do, it's Ralph VK3Z double ZC, VK3VJS and group, well, diminishing group VK3AML, with a pause for any breakers.
Well, I can't hear anybody here. Yes, okay, Chris. And as I mentioned in a comment to you, Warren's call sign is 3LX. And I have one of those radios which you've seen in the museum. It's not working. But Peter, 3YE, gave me the complete service manual for it, Chris.
Oh.
So I don't know whether I'll ever get it going or not, but it looks good in the museum. And we got a few other things from the HRSA today, especially a Polish 4 miniature valve radio that runs off batteries to go in the museum, long wave and medium wave, and a little small scanner that seems to work okay, and a BTM, I think it is, colour pattern generator. Very small. So I might fire that up one day using an old PAL TV, just to see the nice pretty colours on the screen, Chris. But come to think of it, I've got a couple of portables, little ones. Yes, that'll be interesting. I might fire that up. Let's see. Yeah, seeing there's no more PAL around. And a few other little things, knick-knacks, microphones and some old magazines, etc., etc. It was a good day, so I'm glad to Anthony for giving me that phone call at the right time. Anyway, I'll let you go, Chris, and thanks again for those experimental transmissions. They're always greatly appreciated. VK3AML and anyone else that can hear me, VK3VJS is clear. Good morning.
Yeah, thanks, Jeff. And with regard to the comment that Dave made, I think the quality is better on the stream from the slightly compromised audio from the video of Mike 7MJ, because I'm using more compression on the radio than I am on the stream, which has a lot more sig to noise, of course. And the compression would be bringing up the background noise, the coffee urn and the air conditioner and all the rest of it. Something that rarely people that are making just a check video do is to get a microphone as close as possible to the person being filmed. And really it's, as Dave 3ASC frequently says, it's the audio rather than the video that usually carries recordings of interviews. And so I had to do a lot of equalising of Mike's session because it was recorded in a room with a lot of echo, hooty sort of echo, which I was able to get rid of, but it's really only cosmetic. To do it really properly, I'd have to get Mike in front of a decent microphone with a recorder and do it his spiel again, which is very difficult to do, particularly as Mike lives somewhat south of Hobart in a place called Margate. And hello to Mike if you're watching at any stage. Anyway, I'll take a final listen and then go QRT. VK3AML just standing by if any further comments before we close.
I'll just make another comment. At this sale, I bought myself what I call a Leyden jar, but somebody corrected me and called it something else. It's in very good condition. It does have a crack down one side, but that's on the shelf in the kitchen, would you believe? I got it for the right price. Anyway, I'll say good morning again, and thanks, Chris. Cheers.
No worries. You can probably put biscuits in and you can have 1,000-volt biscuits.
Thank you.
No worries. VK3AML now closing. And for the people on the stream, I'll just check. Good night to Paul 3HN, Jared, Mark Harrison, and thanks for the offer of the spare 2N301. If I blow it up in that bloody radio, you'll be the first to know. When I come back next week, I'll have some more shorter video clips, and hopefully a little bit on crystal set design, which a lot of people seem to be interested in. So with that, I will cease the stream. Wish everybody a very good night. Thank you for putting up with the false start. I see we've had 71 views, which is not a bad start, and the average viewing time has been 37 minutes, so obviously we've been keeping a lot of specialist niche interest people with us, and thank you for attending, and hope to see you next Saturday night, 9:30 p.m. Melbourne time, 11:30 UTC, for our next test transmission, as it were. VK3AML now closing on the stream.